minutes to pray for us. I see he's still trying to settle down and he's had the bad side of the stick at the gate trying to access here. But because he's a priest, he managed to get everybody in here. Thank you, Azwi. Thank you for even helping us with the security issue. I thank you. Just let's bow our heads. Yeah, you can. Oh, come here.
Yeah, no, thank you. Let's pray. Father, we thank you for this wonderful moment and the opportunity to advance our country forward. We thank you that, Lord, you have given us wisdom and understanding. As we're starting this function this evening, we pray for your help so that we can be clever, so that we can be smart and be able to build a country going forward. In Jesus' name we pray. Amen.
As I see our program director, I will give her 1 minute to settle down. But maybe let me talk more about ELP and why we were formed as an organization. There will be slides that are rolling in. I'm not going to even look at them because of time. But we were formed out of agitation that there was even leadership in the country that did not believe that we have skilled engineers within South Africa. And there was an inkling need that they wanted to import engineers from Germany, Italy, and everywhere. That was around, it started around 2016, and I think it had happened before, but around 2020, this mobilization started, and we were angry that we are not being recognized as skilled engineers. Amongst us, we have people that have even become professors, doctorate in engineering, and have done big things. And we thought to ourselves, it cannot be that we're going to study engineering, but whenever we needed to practice, some people from overseas will come and do the work that we should be doing as South African. An engineer's mind is a mind that is trained to analyze challenges and provide solutions to those challenges. And with the really broad thinking systems engineering mindset that we have. It cannot be then that if something new comes, then you want to bring other engineers. You need to immerse the same engineers with or without experience, but the mind is trained to look into a problem broadly and think systematically up until you provide a solution. And that in South Africa, I think they've missed that a little bit. And whenever there's something new, they think somebody from elsewhere must come. And this organization was formed. And we are doing quite a number of things, but we are an organization that is not linked to any political party. But we do believe our members could belong into a number of parties. But what we drive is that whatever is a challenge, we will not go on radio and complain about it. We will not go and write on Twitter and everywhere. But whenever we write, we must write an opinion piece that provides a solution to those problems. And that's how we are driven, and that's our base. And we want to expand ourselves into even advising government when it comes to engineering matters. We've had even issues that were during load shedding. People that have never seen a professor or have never seen Newton's law presenting as energy experts. And that angered us. That who is this guy? We know him from university. He was doing communications. And he was doing marketing. All of a sudden, TV has made him an energy expert. And he talks. But he's very generic and he will never go technical because he's not there. So we had such issues, and this is the beginning of a journey to try and resolve those issues. And we will be having all these kind of seminars. We mobilize our engineers in small groups and sometimes in bigger groups to look at various problems. Like, for example, one of the key load shedding issues that would have affected us if we didn't start the discussion with DMRE was the issue of fuel. We had 6 refineries in South Africa, but we're remaining with only 2. And the rest were importing that fuel from overseas. And we're saying, if anything can happen, the Russian-Ukraine war started, and it could be any other that starts. We could suffer because we don't have sufficient fuel that is built locally or that is refined locally, and that could plunge us into a crisis for fuel. And we looked at issues like we have statistician general, we have Velua general, we have a lot of generals under various disciplines. But South Africa spends, their highest budget that they spend is on infrastructure, be it is new project or maintenance or repairs or whatever. But we don't have engineer general. Why? Our growth and development is embedded in engineering being active and engineering being well controlled or being well regulated in a manner that whatever we develop towards or we build, it's embedded in engineering, in technical know-how, and we could look at, because when you look at the design, certain design you need to look at, for example, in civil engineering. When you build a bridge, you don't build a bridge for 10 years. Some bridges are built for 100 years and are built for various conditions, for various weather conditions that could come in 50 years, in 10 years, and in 100 years. But so you cannot then not have an engineer general that oversee that all those steps have been taken and things that we are building are not gonna, with the first rain of summer, get washed away. And we are calling for that, and it's a discussion that is ongoing with government. So we're not just a people that are mobilized to disrupt, but we are mobilized to provide solutions for the development of our country. I thank you, that's that, but I will let the MC take over from here. Program Director, my colleague, ESCO member of ELP, Engineering League of Progress, Valerie Huma. Lerado is, I don't know which one you like, I remember there's one that you don't like. Lerado, over to you, my sister. I'm so sorry we started late, I repeat, but over to you, my sister. We're gonna just go through the program and really take it as fast as we can. And I'm welcoming all the speakers as well that have made it here. I see Prof. Majosi, I see Date Mondemondi, I see Azwi is also here. Mboneni is going to join us online. But Prof. Bismarck has sent his apology not to be able to come because he just had a family problems before he could attend to this. So we have 4 of our 5 speakers here with us. May you please just clap hands for them.
So, evening engineers, I'm assuming there are students also in the room. Yes. Yeah, okay. So I used to be a UJ former route person back in the day doing electrical engineering here. But welcome. It's quite an exciting event for us as ELP, and the reason is because as practicing engineers, we constantly get inquiries from within the companies that we work in around the competencies, around the competencies that they get from graduates. So I'll give a bit of my background. And also whether when they come from school, are they really market ready? And when you say market ready, companies, they expect certain proficiencies from a graduate, such that you're able to first onboard and understand your assignment. They also know that you're coming from a place of theory, depending on whether you did the engineering stream, degree stream or diploma stream. And as such, there's certain fundamentals you need to come to the workplace knowing as a graduate. And that being the case, the expectation is that as a young person, you need to understand how to flip your mindset from being a student and coming to an organization that's in the business of making money, where they're employing your skill set, they want to deploy it so that they can solve solutions, sell those solutions in order to make a profit. And as such, learning happens, but it happens when you produce outcomes that are available. And that being the case, in today's discussion is to really bring that context to say, how has education progressed to align with the skills of today and the skills of the future? When we educate ourselves, we don't educate ourselves for the history. We prepare ourselves to solving the problems that are current and that are coming. So we want to have a discussion and to get that context. So that's why we have Prof. Majosi coming in, just to give us that context to say, how has education and curriculum really aligned at institutions to those skill sets that are required for that future? And then following that, we need to have an industry perspective. What is the trends that are emerging from industry around deployment of engineers and the outputs that they're getting from the engineers when they have to do real work on the ground? And with that said, we need to understand what is the gap of bringing them on board to make sure that the skill set that the workplace requires, that they need to train these engineers or this graduate, how long does it really take for that to be imparted for the graduate to become a valuable member of the workforce? So we need to bring that industry perspective. And then following that, we have to acknowledge what is our current challenges. And what are the challenges? We're living in a world today where there's is it generative AI, ChatGPT? You can literally write a thesis in your first 3 months of university today, if you know how to prompt this thing, right? You can have a report, you can do a presentation for you, even speak for you. But that means we run the risk of not developing the depth in knowledge that we require and the understanding in fundamentals that require in the engineers and even any graduates for them to be able to take in information that comes in the workplace and be able to apply it. When we train engineering, I remember my professor said to me, you're not here to become a control specialist. We're here to teach you how to think. And that is why we have engineers that are in banking today, engineers who are in HR today, and it's because of through our training, we've been taught a way of thinking that enables us to solve problems in society. So if with now the current generative AI, you have someone that does the thinking for you. So that means that thinking muscle will never be exercised the same way. And they said you become better and proficient through practice. And practice means you apply the fundamentals, you go through the pain of trying to solve and apply it, and it's iterative up until it sticks. And when it sticks, then it becomes a natural response. Whenever you need, you know how to put it out of your cognitive memory and apply it. But if you don't practice that, then you just focus on ticking a box because you just want to get a degree, then you run the risk that the certain things are going to miss along the way. And what does that mean? It means the problems that we have today and in the future, we might not have a cohort of engineers that will be able to solve them because they've never gone through the practice. And that's the deep work. So in as much as these things are here, there's a lot of requirements from you as an engineer to restrain yourself and to start saying, how does this benefit me as a person? Yes, I'm able to do that assignment on time. I might get 90%, but what am I robbing myself? Because it will catch up with us, you know? So in the workplace, we use these things so that we can produce results better, but we also realize that if you don't know the subject matter, you don't know how to interrogate that information to assess whether it's correct or not. Because it will always give you words. It will sound like great English, but does it answer the questions and does it solve the problem? And where is your verification platform if you don't have the depth in the knowledge. So we need to ask ourselves as engineers today to say, how do these tools equip us, support us in our learning journey, but what else is it taking from us, and how can we put stop guards so that we don't lose sight of the importance of doing the deep work. The deep work is important, guys. So without further ado, we don't have a structured program, but I'll be calling in our speakers and they'll come in introducing themselves. Prof. Majosi is going to bring us, as I said, that context as to say, where are we on the curriculum and what are the institutions looking at to make sure that when you come into an institution and decide to choose a UCT, a UJ, a VETS, what is it that's planned for you in the curriculum to really prepare you? And what are the insights they're bringing in from the industry to make sure that they continuously improve the content that you learn in class to ensure that when you finish that 4-year program, you are ready for the market and you're able to actually deliver. There's no expectations from industry that you'll deliver great results in year 1, but there is certain things that you need to have as a minimum, as I've mentioned. And those are non-negotiables, and he's going to take us into that. And I hope that you guys prepare your questions. It's an interactive session. You guys are in the school environment. So you need to use this as your checks and balances to check whether every day when you come to school, are they teaching you relevant things. So please engage with Prof. Majosi as I'm calling forward. Please, sir.
Thank you very much for that introduction, Valerie. I always say, for any human being, talking for more than 10 minutes means that somewhere you're talking a bit of nonsense. It is difficult to speak for 10 minutes consistently and only talk sense. But once in a while, I deviate from that rule like this evening. I think what you said is spot on, by the way. I mean, really, from the time we stood up here, you solved the problem so well. Good evening to everyone. I won't be long. I had a presentation, but I don't think that we have time for the presentation given the time of the day, so I'll speak off the cuff. And then this is mainly meant for us to engage in the meeting. So rather than having a presentation, we had your own lectures this morning and everything. Let's get into a different mood now. So it's true that we live in a dynamic world. So whatever we're talking about now, we should always be mindful of the fact that we are responding to the world as we see it now. It will be different tomorrow. And I think that should have the crux of whatever intervention we make. We've crafted the problem statement here to be very much engineering specific, but truly speaking, this is happening across the board. It's not just engineers who are finding themselves in a world that is changing rapidly at a pace that almost no human being can catch up. Any field is like that. But we framed the problem to look at just engineers. So the big question really is, what is the graduate of the 21st century? That should be the question. What kind of a person will survive, and what kind of a person is likely not to survive? And there are a number of factors here. As engineers, of course, we have to understand the nature of the problem that we're trying to solve. One of the things that is very clear is the issue of uncertainty. During our time, and when I say my time, I finished my first degree in 1994 at the University of Natal. This was a long time ago. There was a lot of certainty at the time. I mean, you knew exactly when I had my degree, this is what is going to be expected of me. The world is no longer like that anymore. It is very, very complex, sometimes totally discontinuous, where things were connected before, they're no longer that connected. You have to figure your way through all that disconnectivity. So what exactly then do we need to give our students? And let me paint the picture for what it is. The truth is, for all the years this change has been happening, particularly the academic space has not moved fast enough. We've actually lagged behind the industry. I'll give you the figures because we're working very closely with industry. When I finished, I recall vividly that it would take about, say, 6 months at most for an engineer to really adapt and then ultimately hit the ground running. There's always the transition period. At any given point in time, we expected that we have to cross that bridge. But it took about 6 months thereabout. A year was very, very long. And most of the good solutions came from the young graduates. It made sense because they're coming with that fresh eye, which is not there. You know, when you've sat with the problem for a number of years, it becomes so normal to you. But when the young mind comes and says, come on, this doesn't seem to be right. And I'm not going to list the number of things I myself changed when I was a young engineer. There are a number of things that I did when I came in, not because I was smart, but it just did not seem right. But after that, I was part of the furniture. There were no longer any problems. You know, it was only the new guys that came in and said, but this is not how it's supposed to be done. Today, that 6 months has moved to about, say, 18 months to about 2 years. It takes about 2 years now for a young graduate to actually respond positively and start adding value. This is what we get from industry. And although I'm now the Dean of the Faculty of Engineering and the Built Environment at Wits University, I work a lot with the industry. And I spent 10 years in the industry myself before moving over to academia. So I understand that space quite well, and it's important for every engineer, whether they're in industry or they're in academia, to have that experience, because we are in an applied engineering or applied science world. So we have to really apply ourselves in the industry. So that has gone now to about 18 months. And now the question arises, why? There are a number of reasons why academia in particular has not advanced that much. As you know, our profession is an accredited profession. I don't know how much time, Valerie, you are giving me.
I'm going to give you exactly 20 minutes.
Okay, no, that's so you indicate. My lectures, by the way, are 45 minutes. I don't know if you are aware of this. So I usually talk for minimum 45 minutes, but using, of course, slides. So please, you indicate when it gets to 20 minutes. I'll try to be as efficient as possible. Our profession is an accredited profession. And that, for some people, has proven to be the hindrance. The thinking is that we should do things this way because we are benchmarked this way and we are accredited this way, so things must stay this way. This is what has been the problem for us. I teach a course in third year chemical engineering called Transport Phenomena. It's a very abstract course about momentum transfer, heat transfer, and mass transfer. I teach that course using the book that I used to use when I was a student. This was 10 years ago now. I'm teaching that course the same way I was taught 10 years later. Now, you don't need to be genius to know there's something fundamentally wrong there. And that's the case. Any course at the moment, 90% of the courses that you find in the engineering curriculum are taught the same way they've been taught for over 20 years now. In that period of sticking to that rule, the industry and the world has moved. So if you come in with that Hagen-Poiseuille equation, people are using other things now. It's something else. I mean, they've got tools that they use for all this. Our students are not exposed to these tools. So this is the main reason why we've really been left behind. So what are we doing now to recalibrate and make sure that we produce a student that will be relevant for the 21st century? There are a number of things one can do to achieve this. And I'll talk from the vantage point of my position as the dean. What exactly have we done at Wits University? The things that are really running as we speak. Not the things we are still thinking about. And there's quite a lot that we're thinking about, but there are things that we've really done. And I think they're shaping up quite well. One of the things that we've done was to set up what we call the Industrial Advisory Board for the faculty, where we've identified the industry leaders. They are part of this board. They act as the sounding board. Basically, we tell them that this is what we are doing, and they're the ones who come to us and say, but what about this and that and that? Because in industry, these are the things that we are looking for. So this is what we did, and I'll tell you what we've just gained out of that kind of an interaction. So the first thing is we set up the Industrial Advisory Board, and I mean, you would know, for example, someone like Mr. Mike Teke, who was the chairperson of your council here at University of Johannesburg, is a member of that board. That's the caliber of individuals that we have there. The CEO of the CSR is a member of that board. I'm talking about decision makers. These are the people who really make it or break it in industry. They are members of that board. This was the first thing, and I think this was really, really apt. The other thing that we did was we looked at our curriculum very, very strongly. There are a number of pillars, of course, that we have in our vision as the faculty. But one of the pillars was this undergraduate curriculum reform. How do we relook at this curriculum so that it speaks to the needs of the industry? And one of the things that we did was to introduce what we call data-driven decision-making for engineering and built environment professionals, because we're a faculty of engineering and the built environment. So from this year, starting from this year in January, February, thereabout, all our students, whether you're in engineering or whether you're in the built environment space, we are doing what is called, this is first year, data-driven decision-making. Because I strongly believe that today, to have an engineer who cannot analyze, using not our traditional fashion of analyzing, but using the data-driven approaches that are out there now, the ability to use, for example, AutoCAD instead of using your drawing board that you used to use. You should have those skills handy when you get out there. No one teaches you that, by the way, when you get out there. They assume you know that. So those few who come with those skills will leave you behind in no time. It's a dog-eat-dog world out there. So we've done that. We've introduced this data-driven decision-making. It's the first step. There'll be a number of other things that we'll do. And again, coming to this issue of being accredited, the biggest problem, even introducing this was a problem for us. As accredited as our profession is, it comes with a set number of credits. So it is expected by the Engineering Council of South Africa that a typical engineering program, and it will vary, of course, depending on whether it's for graduate purposes or it's, for example, a diploma and things like that. But they set a sort of a yardstick in terms of credits. I mean, for us, it's about 560 credits. You expect that. When you go above that, you have to justify why you are doing it. So when you start coming up and saying, we would like to introduce this, the question is, what are you going to take out? And that's the difficult part. So for now, this data-driven decision-making is an elective. And as time goes on, I'm sure that we might find a way of integrating to other things that are a core part of the curriculum. Now, coming to the benefit of working with industry, there are three themes that we've identified as a faculty that we are going to be centering our research and even our undergraduate curriculum on. We've just done some inroads now, made inroads with data-driven decision-making, but three things that were raised by our industrial partners. And that for me was an aha moment, that you know what, this is actually where the problem is. It's a discussion I'm having with my industrial advisory board, and then they say to me, why is it that when we have a problem in South Africa, we seldom see an academic, along the lines of what Palas was saying now, we seldom ever see, Palas is a character for those who don't know. He's also called Palas in his cycles. Why don't we see you guys, you claim you're experts, we do a lot of research in energy, in water, and whatever, but why don't you see you there? People like, for example, PwC, or say Deloitte, or say Kani, are the ones that tend to be the first port of call whenever industries have an issue. When someone has a problem with water, they don't think of Wits University to solve the problem, but they think of the consultants to go and solve the problem for them. Where are you in that space? Because you do work in this area. And they highlighted three places for us. They say to us, the world as it stands now turns on these three things. The first one I've alluded to, digitalization. And I've just given you just the glimpse of it. I mean, I haven't even spoken about cybersecurity here, which is really a very key issue. How many of us are really doing that, even at an undergraduate level? The other one is water resource management. Wherever you are in the world, even countries that have water in abundance, talk about issues of water. Well, what are you doing in that space? And here we understand you might be doing this at a research level, but at an undergraduate level, what is an undergraduate student doing in that area? The third one is energy. These are three areas. The world turns around these three areas. If you could hone your skills just around these areas, that should take you a long way. But not just that, be visible in doing so. Be visible. When there are issues of energy here in South Africa, come out and give us your views. on how we can solve these problems. And some of them are very complex problems, which need an engineer who is trained beyond your bachelor's degree level. You need to go beyond that to really understand what is happening. So where are you in these spaces? We want to see, when there's water, as you know very well, South Africa has the issues on water. How often have you seen a leading academic in water? We've got quite a number of them, really commenting decisively on what the country has to do and what the country is facing, really. The definition of the problem as it stands. In the corridors, we talk about it as academics. In the tea room, we talk a lot about those problems. And good ideas come out in the tea room, but it ends there. Digitalization is the same thing. So we have to be very, very visible in those areas. So for us, those are the three areas that we are trying to do, to focus on as we create this product, which is the graduate of the 21st century. In ending, I'll just give you an analogy of how we've interpreted this. I'm a chemical engineer by profession, by the way. I might have declared that early on. If you think of the problem as it stands, our raw materials are students. Those are the raw materials. When you come from school and you really know nothing about what the university is about, we are the raw material at that stage. But when we leave as the graduates, we are the final product. Somewhere in between there is this process or the reactor that has converted this raw material into the final product. So when you talk about the graduate of the 21st century, the implication is that the reactor has been redesigned to produce that product. But at the heart of this reactor, it's your professors like myself, lecturers and the like. There is very little you can do if people like myself have not changed. So those skills that I learned are outdated. There are new skills now which I have to learn. And the question is, to what extent are our professors really 21st century professors? That's the question we have not even begun to ask. The assumption is that because you have a PhD, then you are relevant for today. Actually, there are many people with PhDs, some of them with my title professors, who are no longer relevant today. But those people stand in front of classes, producing people or intending to produce people that are going to be relevant for the future. If you want a product to be of a certain quality, your reactor must be designed to achieve that goal for that raw material. And that, for me, is also the biggest issue that we have, because most professors are not prepared to unlearn what they learned, to relearn new skills, and to upskill themselves. This is the reality. Most of us think it's done. So I'll end there for now. This was just the message. And of course, as we deliberate further, I'll engage with everyone else. I don't want to start talking nonsense. Like I told you, you're on this to nonsense.
Thank you. Thank you, Prof. Majose. Are there any questions to Prof? I mean, there's quite a lot of insights that he mentioned, so we'll get it. Okay, great stuff. So, Palas, are we going to start with you?
No, I want to suggest, given that we started late, and we're still going to have Prof sitting on those chairs, that we let the speaker speak, take notes on your questions, and then when they are sitting in the audience on the plenary there, then we can engage.
Is everybody comfortable with that?
My plea, please.
Yeah, okay, all right. So that means we're going to have the speakers coming in back to back. Unless if you have a very burning question that can't wait till later because you might need to depart earlier than planned, then we'll take that question. So I just want to summarize some of the takeaways from the session. I think what Prof said is there's quite a number of interested parties who are asking the question, where is the academic voice in tackling some of our current issues in the world? And he also mentioned the three areas that are of interest: digitization, water resource management, as well as energy. And the key question was, where are you playing in that space? And I think one of the reason why this is quite pivotal is really making sure that as a graduate, you start positioning yourself in careers in the areas of interest currently. The issue of energy, we have Azwi coming in from ESCOM. Where's Azwi? From ESCOM, and I think ESCOM has been a topical, I can't even say a topical thing, but for the last 18 months we've heard ESCOM almost daily. Today we don't hear much of it is because ESCOM is doing great things, but Azwi is coming from a department where ESCOM is looking at innovation. And innovation talks about how can we do things better instead of the traditional way. So Azwi, please do come through, and then let's just address the students. And please just record your questions as requested. But Prof, I noticed that you're wearing the periodic table. So they said you are so passionate that you don't only just walk the talk, you also walk the subject, you know? Anyway, so let's welcome Azwi, and then after that we will also have Mr. Mondli also just prepare yourself thereafter. Thank you.
Yeah, no, thank you so much, Program Director. I think most of the questions that we might have for me is, what did you do to end load shedding? So I will expect you to write that question. And we will deal with it thoroughly. Thank you so much, Prof. Majosi, for the introductory talk, and also just really giving us a framework. I think the first time I saw your CV, I wondered why we have problems in South Africa. Actually, I was blown out when I was reading your CV. I said, I couldn't believe. In fact, after you posted your CV and you wrote that long letter, I think some people fell shy a little bit and they never commented. So we were very excited about that. So thank you so much. And then Chair Mapalala as well. Thank you for really this opportunity. I'm just representing my group executive, Mr. Begi Numan, who said that I should come and talk, particularly because I'm driving the new innovation, what Prof was talking about here. I've worked for ESCOM for about 27 years, as long as the same years that Nelson Mandela has stayed in prison. But I have enjoyed it. And I've met all the challenges in terms of, I worked for generation, I worked for transmission, I worked for distribution, I worked for corporate, I worked for technology. So I understand engineering, and I'm very happy for that and proud of that. I'm also, fortunately, I'm a member of the Engineering Advisory Committee for UJ, for this university here. Exactly what Prof was talking about concerning VETS. I'm a professional registered engineer. I'm also a professional registered project manager. The information that is really confronting us, I think Prof has really said a lot about where we're finding ourselves. And the program director indicated that we really need to have a view of what is happening in the industry. It has been very painful for us, and we shared with Engineer Mapalala and the other people who are interested, because there are other people who are not interested, that we cannot afford to have engineers to graduate and go and work at SPA. Last year we appointed some of the engineers. We tried, I think we appointed about 100 as ESCOM. So ESCOM was not that bad. Even during the time of load shedding, we managed to absorb 100, and there is no single company that can really compare with us on what we have done. And I can tell you, without any fear of contradiction, that we have employed 90% of all engineers that you see in South Africa have passed through ESCOM. So ESCOM is a very beautiful organization, and I think we faced our challenges, and now we are where we are. There is new leadership. We have got a new group chief executive, Mr. Dan Marukane, a well-seasoned engineer as well. And we really are enjoying
the journey. And things really are moving on. We are going to approach, I think, about 120 days without load shedding. That's good news.
That is.
It's really good news, and we believe in what the people are doing in the power stations. For those people who might have passed through the power station experience, you will understand the sacrifice that people make when they work. And I can tell you right now that it's not magic, it's not another theory that other people might have started, but it is the sweat of men and women in the power stations who are saying that we are working for our country and we want to advance our country. And they are working very hard in that regard. So I would like to say that we are faced with three pillars. Prof. Majosi spoke about water and energy. Those are the challenges that we as engineers need to really focus on and take ownership and move forward and be able to deal with them. And then our engineering practice will find its value when we actually do that. But let me just point to you that the challenges that are facing South Africa is poverty, unemployment, and inequality. And unfortunately, these are also manifesting themselves in the engineering field. So what I can say is that we as engineers, if we can come up with solutions on those issues that were identified by Prof, water and energy and infrastructure, if we can apply our minds, we will find ourselves in a situation where the engineering profession will be able to move forward. We cannot afford to have any engineer, any technician, any artisan in a country like ours to sit at home or do something else. And not to say that doing whatever they're doing is not right. We're just saying that they need to do what they have been trained for. And we also need to make opportunities for them so that they can be able to contribute towards engineering. I would like to say this, that I've read one article when I was trying to prepare. I read an article, and for some reason, that article was also coming from UJ for some good reason. It was talking about the consequences of not practicing engineering. It was coming from Fiona Tregena et al. These people, they came up with some of the consequences that really confront us because we are not really focusing on what we are supposed to do as engineers. And they've mentioned that this will eventually lead us to low economic growth, and also structural transformation. It will be hindered, and also the unsustainable nature of growth. But I have this proposal that we need to really look at the whole education in general. And I really appreciate what Prof said, what they are doing at this in terms of making sure that they had to re-engineer the curriculum so that it can move towards digitization. But some of the things that we really need to look at, and I will just give you 3 items. And one of them is going to be an intersection point with what Prof said. One thing that we need to do, and every university needs to do, is digitization. Most of the skills that are needed these days is more digital than really applying your mind. You need to really be familiar with AI. In the 1990s, when I was doing my junior degree, I used to program in DOS. I was doing computer science as well. I used to program in DOS, and also we will enter into the operating system using DOS. And when you do programming, I was using Pascal. I don't even know whether that thing is still there. Now you talk about Python. I had to go back to school to learn Python and understand the C++. Those are the things that came whilst after we have gone. So we need to really revive ourselves and our thinking to make sure that we are not left behind. And we have introduced, at ESCOM, we have introduced a department where we look at data analytics, exactly what Prof you have mentioned. Data analytics, you need to have the ability to interpret data. And not only to interpret it, so that when you put it in the machine, you don't get garbage in, garbage out. So you need to really be strong on digital analytic, and those are some of the things that we're going to ask you when you are called for an interview. Whether you have worked or not, we would like to find out do you have an understanding of data analytics? If you have the opportunity and you are doing some courses and you really have maybe some time, spare time, just go there and find out what is data analytics. And another thing that we really need to look at is to look at, I think Dr. Mboneni is going to share this with us. He's going to use that approach as a graduate from Da Vinci University. They argue that when you look at a system, don't just look at the problem as such, but look at the whole system and find out what are the causal effects that are caused by some other things, and go and remove those. By looking at the whole total system, you will be able to solve the problem that you have. And if we diagnose the problem that we have in South Africa, where most of the engineers are not working as we speak, we've got almost 10,000 people who are trained in engineering and they are not working. Why? Because those of us who are in the engineering field, we focus mainly on what we were doing and not to focus on the new generation that was coming behind. So those are some of the things that we really need to look at. And one important one, this one I like, is to understand value chain. I'm going to talk a little bit about that for about 2 minutes so that you can have a view. Value chain. We need to know how to create value in everything that we do. And I will give you an example. When you create value, you lead yourself. Let's say, for example, you have got a product you are talking about. In order for it to be sustainable, you need to make sure that it's operational. And when it's operational, you say, what value can I add so that it can come in scale? And after that, you say, what skill is needed so that I can be able to come up with my product? And then you will have your training that will support the skill that you need. And in an environment like us, we've just started a department at ESCOM in Generation, which is called New Business Engineering and Innovation, Engineering, Innovation, and Localization. The intent is to make sure that whatever we are doing is done in South Africa. Gone are those days where we are going to call an EPC company, engineering, procurement, and construction company. They do everything and we are just watching and we end up being project managers. We want to be design engineers ourselves. Now, this is what we are currently doing. Now, if we have to form a department just to cater for people who are coming down the pipeline, it shows that what we are doing is quite important. So that is basically what we have done. And the main aim, if you can, I wish you had this opportunity, unfortunately at a clash of meeting, to meet our group executive, Mr. Begin. He's so passionate about students. He's so passionate about people who are supposed to do things. People who are supposed to design. People who are supposed to work. All sectors, from TVET to universities and everywhere. He says we need to, instead of paying maybe another company 100 million, how many people am I going to employ? Who will come? He has even added another part in my department, the same department that I've mentioned. He said you must have another corner where you employ, say, about 6 to 10 people, and their job is just to think new ways of doing things. And I was blown out. I was blown out and I said, this is an opportunity that we really need to take by both hands. Now let me give you an example of what we have missed recently. From about 2003, we got involved in renewables. You might have heard many people talking about it. But little do they tell you of what had happened. Yeah. There's something that we really missed. There was a challenge that we needed to incorporate renewable energy into the system. And yes, we did. We spent something about 20 billion. And guess what? Majority of those solar panels that were utilized were imported from other countries. And that is the challenge that really confronted us. We spoke to the government, DTI, Department of Trade and Industry. They are coming on board. They are saying, really, you need to start making something. You need to really move. We have met with Dean of Engineering, Prof. Mashau, and we indicated to him that these are the programs that we are involving on. And he is really liking what we are doing. And all what we can do is to work through in collaboration with all the universities. The university here, Wits University as well, Nelson Mandela, all universities. We visited them during COVID when people were bowing down and putting masks and not traveling. We were moving around with universities and saying to them, please align to the programs that we are running out. So those are some of the things that we needed to do. And then we were faced with another challenge as well. The other challenge, we have just implemented a program about 8 billion already, building the battery energy storage systems. When we were doing that, we indicated that we need to do something about it so that those batteries can be manufactured here. And then we missed an opportunity. Guess what? We have already implemented about 3 of them are going to be one is already in operation, 2 are going to be commissioned in the next 3 weeks or so, and then others are going to be started. People are already on hitting the ground on those projects. But guess what? All those batteries are going to come from other countries. So the skills are imported. What we did, we exported our skills and imported the products. So the onus is upon you and I to join hands, and we say, let us build this country. We are the people that are supposed to do it. And Engineer Mapalala, as a chairperson, he indicated that most of the people who used to comment, I've never seen Prof. Majosi commenting about the engineering on TV. And I don't think he's so TV shy that really he didn't want to be in front of the TV. But I don't know whether it was deliberate or not. But I think this is the time now where we need to go there and speak as engineers and explain to people what is actually happening and explain to people how we develop the product, how do we commercialize it. And watch out, there are a lot of projects and products that we have already identified, and you're going to see them and you're going to hear manufacturing plans so that we can be able to come up with solar panels as well as battery energy storage system. Those are some of the things that we are embarking on, and we are working very hard. Next week, tomorrow, we are meeting with Nelson Mandela University, where they are showing us their IP on the development of a solar panel that you have never seen. You are used to a solar panel that is flat, that you put on the roof. That one, you can build a house with it, and it becomes a self-sufficient house. So that is what we are going to do. And we are going to make sure that we operationalize everything that they've invented, and we are also going to have a manufacturing plant and do exactly that. So just as to save time, I just wanted you to have those 2 projects and say that there are many other things that we are doing. Making sure that part of our stations, we are going to refurbish them. And when we refurbish them, we need new blood. We need new skills. Software engineers. My group executive, he said, go and appoint people who are brilliant. Software engineers, people who are able to program a microchip. You know, during my time in the 90s, we used to use Motorola 8080. I don't know which one you use now. But let me tell you, we need to really come up with new innovation. We use AI, we use digital analytic, and we come up with things. Otherwise, other people, we are seeing other nations, they are sending 25-year-old. We are teaching them to do what they are supposed to do by their host nations. They come in, they just move, they say, what do? We say, here you do this. And all what they get more skills, and we pay them for that. And yet we have got engineers who are around, who are able to do exactly that. So don't be amazed when we come and we say we just want only brilliant people who will be paid to think and to program and nothing else. That will be your job. It's an innovation center. Hence, I have that value, that word which says innovation as part of the department. So those are the things that we are going to do. We are going to reprogram the central process analysis units. We make sure that we go into that. There's nothing that is going to be called a black box. We will open them, reconfigure them, and make sure that we run those stations. And let me tell you, with the brains that we have, the universities that we have, the skills that has been put to them, I can tell you that we are able to do it. So ladies and gentlemen, I'm here just to say and to stimulate your minds that just wait. Next time you need to see engineers commenting on energy-related issues. You need to see civil engineers who are transport specialists, road specialists. They should talk about bridges. Not somebody who just really moved from somewhere and he tells us about things that do not abide to Ohm's law and Lagrange's equation and Cauchy-Riemann equation, you know. All those things. We went and did the studies. And when we come out and they talk, we say, I think they are right. We become apologetic. But ladies and gentlemen, the time of being apologetic is over. And that is why the organization that we have is called Engineering League of Progress. It's a league of progress. We need to progress, and it's a league. So you understand, when it's a league, what does it mean? So those are some of the things that we are going to do, and we really call upon each and every person, both online and you who are sitting here. We are saying that let's join hands and make sure that we build our profession and make sure that South Africa is not the same as it was the last 20 years, the last 10 years. We are changing completely. And really, all what I can leave you is really the passion that my group executive has. He says, you know, all these things, we need to just go and do it. We will learn as we move. Some of the space, we need to manufacture them here. And we listen and we said, you know what? We have got brilliant people. I've got one of the brilliant students here called Mondli Dlamini. He was here, I think, about 7 years ago. He did both BSc Engineering, Electronic Engineering, and BSc Computer Science. He graduated at the same time. And this is the man who is able to, when we talk engineering, he says, no, here you are not right. Please move it this way. And then when we move to the computer science, he says, no, here there's going to be a problem. Those are the brains that we need. So we are so excited that we are joined with the young minds who are able to conform to what we are aspiring. Some of us, we might not be able to reach there. We are like the Moses. But the Joshua of this generation must stand up and move forward. Thank you so much.
Thank you, Mr. Azu. Are you guys excited? Yeah, are you? Yeah, but you don't sound excited. Engineers, yeah. Me, I'm excited. I did my EIT training at ESCOM, and we definitely were not talking this language. We're doing electrification and all those type of things. So to get to hear Mr. Azu say this, I wish I was like 20 years younger, so we can, you know, do all those things. And hence to say the Joshua generation, which is you guys, need to come in and take it to the next level. We also have our engineers also joining online, and these are the practitioners as well, and they're taking notes. And some of them are sending questions, and they say they wish they were in the room and listening to this, because when we were training as engineers, we never had industry experts coming to talk to us who look like us, you know. Most of the time it was someone else that you're thinking, oh my goodness, will I ever be that person? But I think when you have someone who looks like you, who's accessible and familiar, it makes this thing look like it's possible, right? It's not a dream that's going to happen somewhere in the Bundus or in Taiwan, but it's going to happen here in Africa. And Africa is the future. And as Mr. Azu say, innovation is a buzzword. I'm in the mining industry. We, in my company, started an innovation department, and our CEO says there's no way we're going to exist in 5-10 years' time if we don't innovate, if we don't disrupt ourselves. So all of these things, they say you need to come in and disrupt yourself. So today you're probably thinking, you know what, all I'm just trying and focusing on, and I'm speaking to the students in the room, is can I just get through and graduate, and everything else, I'll see it afterwards. If you are thinking like that, please stop, because you prepare yourself for where you're coming today, and it's around your mindset. And the practitioners also who are online, they probably will tell you that in the engagements that we are having in our forum, as you said, Engineering League of Progress, we have so many frustrations around the challenges that we have in the country, but we continue to challenge ourselves to say, what are we going to do about it? It's great for us to talk about how there's issues of water quality, as Prof. Majus was mentioning. There was an issue of load shedding now that we know that the likes of Mr. Begumalo have come in and have done the works and have lifted us out of the dark ages. We're literally in the dark ages. What else is next? And hence we need to have a discussion around how do we prepare for our next, because our next challenges are coming. It's just a question of when, not if. So Mr. Mondi, please come through. Mr. Mondi is coming through from Nexa. So we're still in the theme of energy, and I think now nuclear has become a buzzword. Coal is seen as a yesteryear resource for our energy, and nuclear now is going to become the basis and the foundational enabler of us having a new power base. And power base means to be able to help us achieve our developmental targets as a country. And as such, it's going to give us insights of what's happening into that space. So please just be alert, because we're not talking historical, we're talking to what's coming ahead, and how can you position yourself to take advantage of those opportunities as and when they come?
Thank you. Thank you. Unfortunately, I prepared some slides, Prof. I'm not a lecturer or a professor yet. But there's one thing I like about what is happening in the room. The two speakers before me are very passionate about their career. And I'm not an engineer. I must first declare that. I worked with engineers in various areas. I worked in the rail, I worked in local government, I worked at Nexa. Actually, I even worked in the consultancy space, leading one of the divisions when I worked for Royal Haskoning. I worked with engineers reporting to me, all those people. And there's one thing that I would like as we come from the time of MS-DOS. We are addressing people of modern technology. That's a problem that we would always have. I suspect I missed an opportunity when I passed my matric in 1984. Many people were not born yet here. And I had this interest, but circumstances then were not as good as they are now. Let's start there. You didn't have mentors, you didn't have people to look up to. The question of career guidance or seeing the world with the right eyes was not there. Where I was a black child like yourself, but in the worst situations. I think it's important that we look at that. And we are lucky that we have people like a Prof now who can stand in front of us and say, this is one of us, and he went through all those situations, and at some point he emerged as a professor in the field. It says us as black people first, and South Africans second. We are not the last in the line. It's us to build the future, and engineering is at the center of that. I think that's what the two speakers was talking about. Mine, I tried to prepare something. I'll skip around, and I was looking at, remember when you are asked to make a paper, first you say, you look at the audience you are going to address. You are in the space of engineering, you are learned. It's important that I don't talk much from the cuff, but I'll try and add my cuff in between. One of the issues that I picked up in the research that was done some time, I think 2 years ago, is that engineering is amongst the areas where there is unemployment. And at the same time, I looked at the data or the research work that is there. Is also, they are still saying, the same information is saying, the STEM subjects are the future, yet engineers are unemployed. The areas of demand then, they were listed as electrical engineering in that research, mechanical engineering and civil engineering as the top 3 scarce skills. And I, as a person who is in the recruitment space, I disagree with that. We get a flood of these, and why they are unemployed. That's a question I was trying to answer in this. We do get application, a flood of them, but why are they still unemployed? Do you get that? And the same research continue to say that it's actually, I hear that we are cloning ourselves as the people from the previous generation and cloning ourselves on yourselves in terms of transfer of knowledge. But the reality is South Africa is amongst the best countries that produce the best engineers. In ourselves and ESCOM, we have a problem of engineers that are, in particular in the nuclear space, us and ESCOM, because we work with ESCOM on the nuclear side, that are taken by Abu Dhabi now. Abu Dhabi is leading. Turkey is leading. We also have young engineers that I also accepted that they can go, that have joined the IEA, which is the International Nuclear Energy Agency. Do you understand? Why they are recruiting from South Africa is because our universities are not at the bottom. I think when you walk around and you are unemployed, don't say you are the West. You are not employed because the skill you got from the universities is poor. I think I needed to clear that part. The level and us, because we're in the nucleus place in the country, only 2 plants that are in existence is Kupek and ourselves, Nexa. And who are our competitors? Our competitors are all over the world. We have, I tell you, in every country that has nuclear, in particular America, I tell you, in particular America, has taken a lot of our people that worked on the PPMR program. Most of them, they were taken by America. Forget that other institutions now are taking their own from us. And I'm talking about a mix of race. I'm not talking about maybe white or what. Everybody is just attracted to go and work abroad. So that's another point I wanted to clear, that we might be facing unemployment, it's reflected as high. The reality is we are competing like any other country in the world of engineering, and particularly in science. But the only issue that I can also mention at this stage is that the only problem we have with our own young engineers, they're impatient. Those that are employed, they come in, they get registered, they start looking somewhere. Now, the moment you have engineers that are in circulation, maybe 1 year, 2 years, 18 months, I've seen CVs where a person has 18 months, 1 year, 6 months. How can you appoint that person? Because that person has never started a project to the end, cannot claim. When you are a civil engineer, you must be able, when you drive around and say, I worked on that bridge. That bridge has my name. But if you stay for 3 months, you will never have that experience. You'll have many years of work, but we'll never recognize as employers as an experience, because we want people that will come in, produce, work, design, maintain, and go and sell themselves. That's a profile that we're talking about, if you want to be the best in the field. That's one part. But the question I had that I was asked to talk on was also to look at what the changes that could be looked at in terms of curriculum. I did talk, I will talk about that, but to me, it's more about our curriculum is not the West, but there are gaps. Firstly, in my experience currently, is that in particular in the science and engineering, in particular engineering, we'll talk about that. The fact that we have moved from the big corporations like Eskom, Transnet, and PRASA, the number of those corporations is shrinking. There is a number of small, now I'm talking about small, medium react, the small and medium enterprises. Remember, this thing of working with engineers, you end up having the wrong language. No? I want to remain myself, not you. I can't be you. So those companies cannot afford to appoint a person who cannot show value from the first day. The prof was saying, Prof. Machozi, was that for you to be able to adjust to the world of work, in the past it used to take about 6 months, these days 18 months to 2 years. Now you left your first employment within a period of a year. Naturally, the market will start doubting you. Will doubt whether you can produce what, or you still know what you learned from school. Do you understand? So I'll tell you what are we doing on that. But to me, there's a dual role. I wanted to argue on the dual role, that we as people who are in the industry, as stated by Azu here, and the universities, we need to partner. In the partnership, there is part that we cannot erase, which is the primary technical knowledge and skill, which you get from school. That covers the issues of design as an engineer, building and maintain systems, structures, technologies, and the rest. I think that's what Prof was talking about. But to me, there's also the area of specialization. We tended to focus too much on the 5 engineering fields, the well-known ones, and we have a tendency of not looking at other engineering fields like nuclear. I know as you can't come out of school and claim to be a nuclear engineer, but if you are interested in nuclear, start while you are still at school. That's what Prof was saying, and also my colleague here, Azwi. That start research, know the areas where you want to be, and knowing where you want to be, start researching it. If I'm doing civil engineering here, which industries will be of support to me? And what is the core in those industries? Remember, with us, you can ask, I have a colleague of mine sitting there at the back, one of the energetic engineers that we have, and she's sorry now I'm talking about her, but she's working hard to professionalize the engineering field in that company. Sechako over there, Medol, she's sitting over there. And so what I was saying, where she is, she's working in the reactor, inside the reactor actually. She's one of the engineers that are working in the, I guarantee you, if you can ask her, when she completed her studies, was nuclear a major subject in her studies, the answer would be no. Do you understand? But she has been there now, I think it's 12 years, if not more, 10 years. And she's still young. I don't mind that people see you, and do you understand? And these are people who are, she has not been jumping around, and she focused on what she wants to learn, and she's amongst our best specialists now in the nuclear field, although she studied something else. Hence, it's important that we focus. So I'm saying areas of specialization, you don't have to look at nuclear only, but I'll talk about the opportunities that are coming up in nuclear as I'm moving forward. We have nuclear, we have mining, we have agriculture. We have agriculture and other areas of specialization. You'll find that all these areas, these are areas of specialization, but people started somewhere before they got there. So as a student, try and research and look at what is this that you want to be with your studies. Look at the fields or the companies or industries that you think you want to be associated with. Start working towards that. I'll talk about what possibilities that you can do. The other thing to me, I say, in South Africa, our universities are also good in research. I know many people have been saying that our universities are not producing enough researchers, but the problem we have, to me, is commercialization. I don't know, Prof, that would be my personal request, that in particular in the engineering field, can we train our kids to be able to do contract research? Contract research, in this case, you should be able to be called upon by a company, even if you are at home, to say, can you come and design this and this? And they just give you the problem statement, you go out there, you produce, you get recognized in terms of patent, and you get paid. So us, where we are in the process as Nexa, we're a research company. We are in the process of moving away from the academic research. We have produced so many academic people, but because we are in partnership with a number of universities, but we need people who will be able to create things. We are saying here, design, build, and maintain. So that's your area. So those are kind of things that we'd love to see, that maybe in the type of research, we don't put kids too much on, okay, to solve X, but they must create something out of solving X. Thank you. Thank you. So there's also the question of secondary skill. That's where the problem is, colleagues. I think Prof touched on that. The secondary knowledge or skill, to me, is the skill that is complementary to what will make you the best employee. You might be the best engineer, but because we have moved from the big corporates, we are moving to medium to small enterprises. Small enterprise doesn't have that money to wait for you to learn, to grow, to be what you want to be. They want somebody who comes in, within no time is able to produce something that the company can sell. I worked in the consulting at some point, engineering consulting, that is in Woodmead, next to you. There, I remember in that company, we only had 2 specialists in what you call this, the silos, building of silos. Only 2 in the country. Both of them were above 50 at that time. Can you see? And there's no university that is assisting the agriculture space to build more silos. We still depend on them. You know, we were even using them to build these silos in I remember in Nigeria, we were in Ethiopia and all over. Only 2 people. And of course, the advantage is that the pay is good because you know you don't have competition. But I'm saying, as you are a student, learn to research and check what is this that will make you sell when you are in the market. Those are learned on, but what I'm talking about here to me is that the secondary skill, if can be added, Prof, I heard you saying it's always even difficult to change the electives. Because if you add one, the points are going up. The truth is we need to look at the electives and look at which electives are still relevant now. We don't continue with the electives that don't add value. That's one point. The point number 2 to me that universities can do for us on this, even choosing the elective, at least there should be some kind of career guidance. This kid is new, is still excited about being an engineer in the future, and you say you must choose statistics. Do you understand? Naturally, it won't be appetizing. Do you understand? But if we create value, you mentioned somebody I worked with many years when I worked at University at Medunsa then, Professor Satek. Sorry to brag about him. Professor Satek became a professor at age 28, full professor. Professor Satek was a product when he passed his MPCHB. The university gave him just short time to go and do practice and was called back and taken overseas to go and specialize on nuclear medicine. Currently, in the country, he's the best. Do you understand? That's the person you mentioned. He's also served at Nexa as a board member. We work with him currently on number of projects that we are this number of projects in the nuclear medicine. Is one of our point of contact outside Nexa. Is just part of us every day. So I'm saying, let's look at people like those, people who are actually, he's from the township outside, what do you call that township? Just next to Nexa as you go to Pretoria? Yeah, he's from Atteridgeville. Can you see? It's just like us. It's not somebody who's coming from the moon. I want us to look at those. So I think the other issue is a question on the job training. Some of the secondary skill you learn as you get into the space of in the industry. But like for simple things like report writing, I doubt if the curriculum will have report writing in it. But when you join us, at least you must have tried to learn some of those skills. But they won't penalize you for report writing, I must be honest, when we shortlist. But your communication skill, you must understand now you are a professional. You must be able, with us, the issue of presentation when we're in the consultancy field, anyone should be able to be given a presentation if your line manager is not there, to go and represent the organization, and that has no rank, so long you know the content. So you should be able to lead in such situations. Of course, you'll be working with people out there. I know at school, most of the time you don't work as a team, but in the field, you work with them. The issue of technology usage, I think Prof went to town on that. I'm not going to repeat that. But there's one part that we picked up, is that the detailed knowledge on, we have a tendency that because we are engineers, we won't touch the spanner. Do you understand? We don't want to do menial jobs because we classify ourselves. The truth is, in the world of work, in particular when you work for small, medium enterprises, somewhere, somehow you are expected to dirty your hands. Even if you are not expected to dirty your hands, at least you must have the knowledge on how to change the valve. And you open it, you look at it, you don't have to send, and so that when you give instructions, at least it's something that you also know. It's a skill that, I'll tell you what we are doing on that, Prof. We are trying to bridge that gap, but I'll talk about that later. The other one is that as a designer, how would you understand if the design was not perfect, the one you are trying to correct, if you can't even open the valve and see what is inside? Do you understand? For you to be the best designer, at least you must know what you are talking about. You must experience it, not to hear. At some point, I hear what you said, and I'm happy that we are moving on the right direction on the NH. At some point, there was an accusation that there are no engineers, we need to import them in the country. But there was some recruitment drive that, in particular, in some of the rail and at ESCOM, to recruit the old guards. But nobody ever checked who are these old guards. Most of these old guards, do you know who were they? Most of them were technicians and artisans. But they were given the title engineer because they've been working there for many years. And why the organization felt after they left, because they took packages, most of them. After they left, there was a collapse. It's because the current caliber of engineers doesn't want to dirty their hands, such that they don't know to open a valve. Do you understand? That's a limitation we have. I think we need to blame ourselves too. Let's not blame those that, let's also blame ourselves that we created that environment. Thank you. Let me run now. I'll move fast. So there are also other areas that we need. For example, we're moving towards, if we were talking about small organizations and we talk about unemployment, can we include programs like entrepreneurship? So that if I'm not, I'm an engineer, I'm qualified, why I can't open my small business there and run my own business on my own without being employed? So these are things to me that I believe the universities can help us with, over and above what kids are doing. I'll try and move fast. I won't talk on this. I had some examples of our adverts. Just in what are the key things in terms of core and support? I'll skip that. But the issue with us, in few words, the main issue we have when we recruit, we do look at the experience, because we are not the biggest of them. We are not in the space of ESCOM, but we do take young people. In the past few years, we have been taking them, sending them overseas for training and specialization in nuclear, in partnership actually with ESCOM. I think we ran that program for many years. It's only in the last year and this year that we have not sent anyone. But we have been sending kids to South Korea, to China, to Russia, and they came back. And because we are who we are, and we have this friendship with ESCOM, some of them, our young engineers who were coming from these programs, we deployed them in ESCOM to go and learn now how to do, beyond just Nexa, to learn engineering from another angle. They stayed there for 2 years, and they came back. I won't say where are they now, because the moment a person is at that level, the market is ready. That's a problem. The competition is also very high there. You develop people, that's why you find that small organizations are not comfortable recruiting young people. They develop them, and they fly out. They follow money, even before they are ready. Sorry. That's one problem that we have, and the question of registration with us is important, but I'll tell you how are we assisting. I won't talk about the terms we use there of nuclearizing people. I won't talk about the terms of nuclear awareness. What we do is that, as most engineers, that lady was nuclearized. There's a language there where you come in as whatever engineer, you are taken through the nuclear programs and you get trained until you become called a title nuclear engineer. You just, and I believe there's one sitting at the back there. Okay, on this one I'll be quick. On this slide, here to me, I think I've mentioned the issue of curriculum enhancement, trying to look at the additional courses that we can do that will help a person to be independent. Somewhere, somehow, let's not create only employees. Let's learn to create people who can run their own businesses. That's one part. And the other one, industry and professional body partnerships. I'll quickly say through the assistance of, again, the same person. There are senior people there, but she has been the driver where we are currently partnered with Engineering Council of South Africa. And in that partnership, we will be taking a number of unemployed young people for training until they are registered. And secondly, they will be exposed in terms of the field of study that they are in, and also we are looking at nuclearizing some of them through that program. And that program, we signed the MOU last year, so we are in that process. And so these are kind of partnerships that even universities should have. Of course, in the science space, we have partnership with other universities, VEDS. We have partnership with Northwest. We have partnership with number of universities, but on the engineering, we have not been very strong on that one, I must be honest with you. Then the other issue, professional bodies, I think we know what we mean. ASWI is a member of 2 of those. And for us to improve it's important that these bodies are part of curriculum development because they represent the industry. Then I also spoke about the issue of maybe there should be some programs that maybe you can have partnering with other faculty, like it's faculty of law, faculty of commerce, faculty of management science, so that maybe a young person, when he finishes his course, can take 1 year in those, depending on the area of specialization, so that they come back slightly stronger. To me, there could be a program around that, so that when they join the world of work, at least they know how to manage what they want to be, depending on the contents and the rest, which would be the part of the discussion. No, can I quickly just talk about this one part? In areas, to me, I decided to include the areas where we need more skill, in particular on the engineering field. I'll mention the issue of uranium beneficiation. We are in the process of reviving that process. South Africa used to run that program and we stopped. And we're in the process of reviving that. It will need engineers, even to restart the plant, because the plant is still there. We have the new build, of which we are in the process of creating another nuclear plant within the. Then we are also we do nuclear manufacturing, where we also need, we are one of, actually in Africa, we are 2 companies that are recognized as in terms of, let me not go there, but we are in the development of vessels that are used in the nuclear industry and the rest. And the other area I can talk about, which we are trying to steal from Eskom, is the question of small, medium reactors. We have made a submission. We would love to enter that space without competing with Eskom. Anyway, Eskom is already working on transferring PPMR back to Nexa. So we are trying to learn on. So all these will need future engineers, not only the current ones, and we'll need a number of them. Hence, we are trying to partner with industry to develop that. But just my last parting words will be, as a young person, you should identify at least a minimum of 3 areas of specialization that you want to, while you are still at school, you are interested in. 2, go and search the industries and check which industries will fit you better in terms of the areas of interest. 3, when you choose your electives, make sure that they are aligned with what you want to be to complete your knowledge and skill. 4, try and identify a person in the industry. When you are mixed like this, when you live here, you should be able to say, Sejago, can you be my mentor? Might be distant, but we talk from time to time, and try and identify somebody to mentor you, to develop you, whether you are a young engineer or for you to grow, you need that voice that will help you to make the right decision. And during holidays, try and check which companies can help you with practical, so that at least in your CV, we are able to see that you were exposed on certain things. At least you know the world of work. And also beyond that, it might make you noticeable when the opportunities come. And as a young professional, please stop job hopping. I think that's my parting word. Thank you.
Thank you, Simon. Thank you.
All right, we're not going to say much. We're going to bring our online speaker, or Prof. Do the 30 minutes panel discussion. So just prepare yourself for the questions. We received a number of questions leading to the session, which we're going to also present here. But the most important thing is the people online and those that are in the room to first air out their questions. So I don't know if Prof Mofo is already on the line.
Can you hear me? Good evening. Can everybody hear me?
Please tell him we can. Tell him that we can.
And I need to really just correct something before another qualification scandal breaks out. I'm not a professor. So when these things come out, they become very vicious. I'm only a doctor, so maybe one day I'll also become a professor. If everybody can hear me, I would just like to really proceed. My name is Mboneni Moape. I'm from the Department of Science and Innovation. I've worked in government and in the science space for the past, very close to what, as we said, 26 years. So next year is going to be 27, and then probably I'll also be able to brag about how long I've been in the system. Now, just to really start off, I think one of the biggest challenges that we need to deal with is appreciating the fact that we have very much been thinking in silos. And the problems that we need to deal with are actually not siloed. And then that, for me, is a very crucial thing. And just to touch on the point that was raised by many of the speakers, which is around the issue of unemployed engineers. The reason why things are collapsing today, whether it is buildings, whether it is roads and everything, is simply because the engineers aren't being employed. And in the absence, so when you look at municipalities, we got people who are leading engineering departments and engineering programs who are not engineers. And that is really why it is important for us, as some of the speakers have said, that we stand up and we really begin to be felt. I mean, I always keep listening and watching television, and I see specialists who are either speaking in the area of energy, in the area of medicine, and so on and so forth. And those specialists are actually not specialists, but it's just really some random person who is very loud and who can actually just become a darling of the media and their calling. So I think that is really one of the things. Now, how do we make sure, for example, that we begin to build a country where engineers are actually appreciated and given the opportunities that they deserve? Because economies actually rise and fall on the back of having and utilizing their engineers. The reason why we are where we are as an African continent is because they say there are more engineers, African engineers, elsewhere in the world than in the African continent. And we then get surprised when our economies are run on primary products. We extract things, we send them away, we buy them again after they've been processed and after they've been worked on by engineers, some of whom are engineers that we have trained. Now, from the government side, the government has got a very important role to play in ensuring that we actually build a cohort of engineers that will be hands-on and that will make a difference. And why is it that we emphasize the issues of engineers? It's because every single thing that you interact with would have been exposed to some kind of engineering expertise of sort. Now, we therefore need to have very big research programs that are focused on engineering. And in the past, we have had a couple of them. Some of them, because we are impatient, we have closed. And I refer, for example, to the issue of the PBMR, which some of you may know. And as soon as we close these programs, guess where all the engineers go? They actually get absorbed by a lot of companies outside of this continent. We have had people who went to the US, in Europe, and so on, who were coming from the PBMR program. We also had a program on the electric vehicle, as early as 2008, 2009, South Africa already had an electric vehicle that was developed locally by South African engineers. But we tend to think very short term. And because of that line of thinking, whatever we needed to invest at the time to get that into the market in a big way, I think at the time it was 15 billion that was required. And we decided it was a lot of money, so we can't do it. And therefore now, everybody is jumping on the bandwagon of the electric vehicles, and we actually are now chasing the tail end of this innovation while we actually could have been leading. And leading actually means that we also have a lot of economic opportunities, employment, and so on and so forth. So that is really why I'm saying it is very important that working ourselves as government, academia, and I'm glad that Professor Majosi highlighted a whole range of other things around what we need to do to make sure that we stay and remain relevant. In research and development, you've got that, open book where you can actually do whatever you want to do. You can dream things, you can research, and you can develop things. And that's really, for me, where the actual nourishing of the new innovations can actually come in. And in the absence of that, every time we're going to think of importing innovations and technologies, even where we can do much, much better. Now, one of the biggest projects we have in this continent, and probably also in the world around science, is the Square Kilometer Array project. And this is a project, again, you cannot run a project of the magnitude without engineers. And when you look at it, the whole world has actually been using this big program. Whether you look globally, you look at the programs like the SEN program, the JINR, various NASA programs. In South Africa, I've given an example of Square Kilometer Array, the South African Large Telescope program. This is really where we cut our teeth in producing top-of-the-range engineers, who in some instances we end up losing. But who really cares if you are losing, but you actually have a pipeline that is coming through? And how does that pipeline come about? It's about creating opportunities through, for example, the programs that Azu was referring to, where as a country, we begin to respect our own engineers. We begin to say, how do we train them properly when they come through the system? When we were going through the COVID challenge globally, one of the biggest reports that have come out says countries that were able to use their own capacity and resources and infrastructure were the most successful country. The whole lot of countries who used consultants that were imported globally, they had no idea and no clue about the actual context of where they were operating. And as a result of that, they ended up not making the kind of impact that they needed to have. Now, what are the programs that we are running currently in government that we see they are beginning to also help us build this capability and the new cohort of engineers that we're going to need as a country going forward? And the good thing about engineering is that this is a very versatile area of work. For example, you can be an electrical engineer, but to do other things is very easy. We have been able to see, for example, during COVID, when we needed to manufacture ventilators, the engineers who were involved in the Joule project, which is the electric vehicle project, were quite involved now that they were part of the SKA project in ensuring that we were able to develop tens of thousands of locally developed ventilators that were relevant to our own environment. And we were using them, we were using our own entities, the CSIR, we were using our technology stations, which are run from the Technology Innovation Agency. And the reason why this then becomes what we call a virtuous cycle is that when we've got programs and projects, and when we have institutions, the companies that we have like ESCOM, continuing to run, is that they in turn continue to train these young graduates that we want. Now in Africa, we always complain about what we call the brain drain. And I always ask when we engage with colleagues internationally, how do we expect a rocket engineer to come back and work in our continent when we don't even have space programs? Do we want them to come here and sell fat cooks, or do we want them to come here and apply their trade? And for them to be able to do that, we are going to need to make sure that our organizations, our entities like ESCOM can never be destroyed, because when you destroy ESCOM, a couple of years down the line, you are going to need an alternative of ESCOM. And what are you going to do? You're going to bring in expertise from elsewhere. They're going to charge you an arm and a leg, which actually constitute what you thought you were saving and more. And that is why it is quite important that we also respect our own entities, our own local companies, make sure that we don't only think about them today, but about the future. And as a whole lot of programs were being mentioned, the issues around energy storage, the issues around the nuclear space. And guess what? The reason why I think Professor who has been mentioned in the nuclear medicine, Satige, the reason why he's staying here is because as a Department of Science and Innovation, we've got a program that is looking at nuclear medicine that he is leading. But the moment you destroy that and the moment you don't appreciate that, we are going to reach a point where as a country, when we've got problems that we could have solved, we will not be able to, because we would have decimated all our capabilities. So we therefore need to have this very strong interaction between academia, government, the private sector, and state-owned entities to make sure that we continue to build. We employ these graduates, we train them, and some of them we train and they're going to go out and become entrepreneurs. In fact, I'm very proud that we are even launching new programs that are looking at developing entrepreneurs. And for us to be successful, these have got to be tech entrepreneurs, not entrepreneurs who are doing catering, and we respect catering. However, for them to be entrepreneurs who are based on manufacturing gadgets that are going to make impact globally, they've got to be engineers and scientists. Otherwise, we are not going to be able to do anything in that regard. So I really want to say there is a lot of work that we need to do around making sure that there is relevance. These entities, they have been used very successfully. Whether you talk about ESCOM, Telkom in those days, they've been used very successfully by the apartheid government to train and develop capacity. And today, we aren't doing that as much as we have done in the past. That's why we've got a frustration of young people, and then down the line we're going to say, oh, by the way, we don't have experienced engineers. But for the experienced engineers to gain that experience, they need institutions that are going to train them and that are going to give them projects so that they can learn. And lastly, as I conclude, I've had a very interesting experience in engagements with the likes of the Chinese, the Swiss, and the Germans. And you see there, when a youngster is 18 years old, those who would have taken the so-called, in South Africa, TVET stream, they would actually be doing things and manufacturing things and be so experienced that they actually are ready for employment at 18. And for us, we are going to have our graduates and we're going to be complaining that, oh no, we didn't really create a lot of, they are not properly trained. During my days at varsity, I used to know that some of you who are engineers here, during school holidays, when we were going out and taking a break, you guys were going to the ESCOMs of this world, to the Transnets of this world, to be trained. And I think that the programs, those of us who are here and are leaders in those entities, we need to massify them, as Ajay has mentioned about what ESCOM is doing. Otherwise, as a country who wants to lead the continent and be a big global player, we are going to be left behind because nobody is going to be trained these people on our behalf. And yes, we're going to train them, some of them we're going to lose them. But if the pipeline is big, when the funneling comes through, we will still be able to have the kind of capacity that will take the country forward. And we also know, looking at what China has done, that even when you lose people, you actually never lose them because you have what we call brain circulation, not just brain drain. The Chinese people who are based in the USA will never forget that they are Chinese. And in the same way, if we build a capacity and a cohort of engineers in South Africa, even when they've gone to Dubai, which is where they have been poached, and other countries in the Middle East, they will never forget that they are South Africans. So they will also be able to be reachable, to be part of the network and the ecosystem that we want to create to train. So I just want to say, let's really take our stand. Let's continue to build this. Let's really look at where things are going. We're running now a program in the department that I'm leading called the NPDO, which is the National Policy Data Observatory. And here we're using data from all walks of life, from social sciences, from engineering, from sciences, from satellite engineering. And this data is being used today to make big decisions in government. And programs such as the satellite engineering that we're running at CPUT, Stellenbosch, and so on and so forth, they are also very crucial in making sure that the versatility that I've mentioned as a source of manufacturing in South Africa actually is maintained. So I'm going to stop it at that, and hopefully we'll be able to take some questions and see how we can actually build what we have been emphasizing that we need as a country to build a capable state. Thank you.
Thank you, Dr. Mofe. Thank you so much. Thank you. Before we go to the panel, we have Dr. Mashao here, Prof. Mashao. So we are in his backyard. So we have to bring him here so that he can address the students, but also encourage the engineers online. I think he got sense of the theme where we're moving. His probably input is just to assure those that are in the room that UJ is on the program, and what you are learning here is also aligned with the future and what's happening outside in the industry. So, Prof, please proceed. Thank you so much.
Good evening. Yeah, it's really not too good to be at home and have people come to your house and you are not part of them. We had graduations today. We were graduating 14 doctoral students in engineering. Yes. So that is why I couldn't be with you at the beginning of this. But I just want to say that, I really appreciate this opportunity. I think we do need to discuss. Here at UJ, we have the Industry Advisory Board. Prof. Pat Naidoo is in charge of that institution, but we have a nuclear research group that is led by Prof. Cornell. So I would, when I'm leaving here, I'm going to just tell them about your group and also the things that you are looking at, because I think it's important that there is some interaction between the two groups. I do know, I was talking to Prof. Cornell today, that they have 16 SLPs, short learning programs, on nuclear engineering, nuclear science. So those courses, you don't have to take them in any pattern. You can do them outside. You can do them outside if you just want to take one of those modules. So Prof. Cornell, Prof. Naidoo will be able to do that. In case you are interested, they are looking more at, they're looking at nuclear. They are very interested in the nuclear build, PBMR, and so on, but they are also interested in nuclear medicine, using it for medical applications. So it will be a good thing. I unfortunately not going to stay, but thank you very much for coming. I hope that next time when we coordinate, Precious, who is our marketing expert, is telling me now that there were a bit of struggles for people coming from outside. And I think it was probably a lack of coordination on our side, because we didn't know whether you had worked with any faculty or any department when you came here. But Precious will always be the best person to deal with, so that when we have visitors from outside, they can easily come in. And we will make those coordinations, and hopefully we will be able to do more things together and discuss this. Prof. Majosi, I was so sad to see you and also the VC. So where I saw the advert for this. I told them earlier, I think last week, Justice Lutuli, and so I told them that I will not be able to make it, but I don't think it reached everybody because somebody did send me a message today as well to ask me when I was at the graduations. I have had a lot of very good advice about your interest. I had a lot of very good advice about studying these things, and I want to encourage you to do so, because we do know that the challenges we have right now, we have a powerful tool in nuclear engineering that if we don't use it, the fact that we don't use it doesn't mean it's not there. It just means we will be behind. So we do need to use it and take advantage of what it offers. Yeah, thank you very much, Prof. Majosi and the other colleagues. Thank you, Prof. Yeah, thank you, sir. Yeah, thank you.
Thank you so much. All right. Without further ado, we're going to start the Q&A session. We are going to ask our speakers to sit here. This is just to let the people online to see who will be speaking. So Prof. Majosi, Mr. Azwi, Mr. Mondli, if you guys can come here, so that you can be in view, and you can be seen, and then we can start with the Q&A. When Prof. Majosi finished, there was quite a number of hands that went up. So we're going to do that. We have a roll me mic. So I'm going to call you guys in the sequence in which your hands go up. So we'll start with you. Also introduce yourself and ask the question. Thank you so much.
Thank you very much. My name is Teslim Yusuf. I'm from the Energy and Water Sector Trading Authority. Thank you so much for inviting me. I only got this invitation yesterday, and it's unbelievable to listen to this gentleman speak. I just want to say something. I mean, it's a mixed crowd. It's a mixed crowd of engineers, academics, and students. So it's a very difficult discussion. But something I must say is business is not in the business. That is, companies are not in the business of building capacity in people. They're actually in the business of what they do, which could be to make money, design structures and all of that. We actually need an enabling environment that requires businesses to do what they do well. And in that process, we need skills, young people to be in there. You talked about a reactor. You talked about the university being a reactor for students. I think the reactor is also the students themselves, to be the right instruments within the reactor. So in my experience, I mean, I've had a lot of people over the years. I found out that young people, like you were saying, are very, very instrumental to change in an organization. And you do not need a very highly qualified individual. You just need a man with the right mindset. In most cases, you would find out that the older people in the institution get bogged down with the culture, and they resist change. They just carry on and do things. It's people that come from the outside, young people that come from the outside, that now start asking simple questions that we cannot answer, and it makes us to think outside the box. So yes, engineering is a fundamental degree in all of its phases, from electrical to civil and all of those fields. I don't even think you need to learn what's happening new. If you leave university with the basics of your understanding, and you as a student has the right mindset, and you're able to find yourself in an environment that fosters development, you will develop. So my call is to academics, to the training institutions, to companies that are hiring young people, but most especially to the young people. There's something wrong with young people. I've been hiring them and there's something not right. They come in with that mindset and they just want to step in and step out. And then lastly, I think I need to say this. If you're an engineer, you haven't gotten a job, do not go take an internship in an institution that does not take you in your direction. It will actually destroy you. And I've seen that happening a lot, where engineers go in and just look for a job somewhere else, do an internship for 1 year, but then they leave that field and they destroy the fundamentals of what they've understood from university. So it's important that you stay the course and find that right path till you get to where you're going. Thank you.
So we're going to take another question. Maybe the next question will be, what are the barriers of entry for engineering graduates, especially in the in the mainstream? Because as we're saying that we would like to connect opportunity with a ready engineer, but if we have engineers who are unemployed, there is a problem somewhere. So where are the barriers? Why are our engineers not employed? So I'll give it to you, Prof. I think you have a...
Yes, does it work? It doesn't seem like it's... No, okay. Or maybe I can talk. So sorry, yes. So just to respond to that very quickly. Regarding development, I'll start from there. There is no doubt in my mind that the kind of training that an engineer gets at university equips them for a very complex environment. So you will adapt. That is true. Unfortunately, time is a key variable today. The question is, how long does it take to adapt? So if it is 5 of you who are coming to Sasol, I'm talking about Sasol because I worked for Sasol for some time. If it's 5 of you come as young engineers from Sasol, one is from WITS, one is from UCT, one is from UJ, one is from there. The one who adapts quicker is the one who's going to leave you behind. So that's why then the university becomes so instrumental in saying, whilst we know that the fundamentals are there, how do we make sure that we rejig those fundamentals so that by the time you leave, we are ready to roll, you know? So that is where the issue really, that variable time is very, very important. By the way, if you look at other institutions abroad, their curriculum is never static. It changes all the time, and I ask them, I mean, I visit MIT time and time again, I ask them, why is your curriculum not static like ours? I mean, we've been designing a reactor, distillation column, pump, same way, and they say that it's influenced by the people that they serve. So when it's biopharma in their vicinity, all of a sudden every engineer is doing biopharma-related work. If it's someone going digital, then you find that most engineers are moving in the digital space, so it changes according to the demand. Ours is not like that. Ours doesn't care about the demand. In fact, at times I even ask myself, do we know what the demand is? So we have to really, look at that very closely. But I cannot agree more that students themselves have a role to play in guiding the direction of the ship. But as to where the barriers lie, the answer is simple. The sink is saturated. That's what I always say. The sink is saturated. I'll give you the statistics. In South Africa at the moment, we say for every engineer, you need about 3,200 engineers. 3,200 people. For every engineer, it's about 3,200 people if you look at the population randomly. So we'd have to get about 3,200 people before we get one engineer in South Africa, looking at our population and the numbers of engineers. If you compare us to our BRICS partners, your Brazil, Russia, China, India, on average, it's only one engineer for every 200 people, which means that you have to increase, if you look at those numbers alone, that's when people say South Africa does not have enough engineers. So we have to increase our numbers 15 times so that we can be on par with our BRICS. The difference is in those countries, they've got sufficient space for those engineers to be absorbed because the economies are structured in that fashion. So when their engineers finish, they go somewhere and work. We don't have that situation. Manufacturing in South Africa, for those of you who might not be aware, has been shrinking over the years. Manufacturing is a home for us as engineers, all engineers. We belong to manufacturing, but it's been shrinking over the years. That's where the problem is, which is why most of our engineers, and I would say about 20, it's going to 30% now, of the engineers that we produce are working for a financial services sector. Most of those engineers, when you ask them, as much as they earn a lot of money there, that's fine. If you ask them, is that really what you want to do? They'll tell you, that's not what I wanted to do. But there was no other place I could go to. I'm happy here, and of course, they adapt their minds are adequately employed because they've got the process systems thinking, which is relevant in that space. But that's not their first choice. It's because there's no other place for them to work. So I really like the suggestions made by both Azwi and Monde, yeah, Mr. Monde, that we have to look at manufacturing closely as a country. I think this was also articulated by the Deputy DG there, that we have to look at manufacturing as a country, expand that base, but also inculcate among those that we train that you too can start your own business. So the issue of adding value, knowing how to add value at a very, very early stage is very, very important. And I think universities in particular lack that. So we have to change it. So with time, I think it will change. But the barrier is that the sink is saturated. Yeah.
Good evening to the panelists and those in the room, those joining online. I'd like to applaud the initiative, the Engineering League of Progress. I think it's a fantastic initiative, and look forward to more talks. And hopefully, when we do more talks, the demographic of the panel also changes, becomes younger. There are more women, there are more women, etc. So that there's that element of relatability as well. My name is Tsohovato Newfan, and my brother Teslim and I are kindred spirits. I think what he spoke to resonated with me. Where I would differ, he said that there's a problem with young people. I think Teslim, there's also a problem with us and the systems that we've built. And sometimes when young people come in and they do the challenging that we like, we say, there's something wrong with you. But speaking to the young people in the room, I'd like to say that you're not the problem. And as Teslim said, you're actually also part of the solution. I'd like to maybe address some of what the panelists have said by way of telling you about my journey. So I studied at a good university, I think. I studied electrical engineering. And when I got out of that institution, I started my training at Eskom. So Eskom distribution absorbed me. And when I got in there, right, there was no requirement for me to get up to speed in 6 months. Actually, as a matter of fact, there was a structured program aligned to the Engineering Council of South Africa that required me to rotate within the organization for 18 to 24 months to get the maturity and the breadth of landscape that would have me move into my third year of training as a person who understands the context, the training. And I also worked on the spanner. So I was doing cable terminations, climbing structures, etc. So the context has changed, and maybe Prof. Majosi can also address that, because the context that maybe when you went into industry and you got into like a single product organization where they're only working on motors, sure, in that organization I can move from 0 months to 6 months and become relevant. But when I move into a complex organization such as Eskom, Transnet, etc., I will require that 18 to 24 months to become relevant. So there's that contextual element that needs to be addressed. And then I went on into the organization, and I got the opportunity to see the breadth of the electricity supply industry. So I was lucky. But in my time, even when you were not lucky, you would almost certainly get the opportunity to become a senior engineer and have a good career. We, and those who have come before you, have changed that world. You are now studying in an environment where the economy can't absorb jobs. They can't produce jobs. So 10,000 engineers sitting at home, part of it is because the economy isn't growing. It's not producing enough jobs to absorb you, right? And I would say, then what? What is the challenge for you? Should you stop studying engineering? Engineering is a great base degree. Other things into the financial sector, there is a demand for those base skills. So addressing the what then question is, what do you then demand from the curriculum that you presented and from your faculty, right? And as I say, one, you demand that they give you the basic skills that are contextual. And Prof. Majosi started addressing it. It was a bit missing in the initial introduction, but he started talking about contextuality and serving industry, and that being embedded in the curriculum. The last one is, how do they train you to become linked up with the problems in your society? Right? When I was studying, they said engineering is science, fundamentals, and maths applied to solving society's problems. So how do you demand from your faculty and from your curriculum to, while you're learning, engage with society's problems? so that when you go out there, you can already see yourself and your skills being applied practically in society, even if someone doesn't come and say, here's a job. So those are the few points that I wanted to bring up. I had a few more, but I think I wanted to speak to young people and say, you're part of the solution. You're studying the right qualification. Even if you don't become a senior engineer or you're not nuclearized or ESCOMized like I was, there's a place for you in society and your base degree and skills.
Thank you, thank you. Yeah. I'll try and be short. Gentlemen, the questions still remain. I think it's the question of the topic of today. A quest to try and make a ready-made engineer. This is a quest to make a ready-made engineer. I think we've relied on our experiences on the model that we've had. As engineers, we got trained in that model, that you'll study at university and then you go get engineering training program of Sasol, Telkom, and other various companies like my brother was talking about. I think the appetite for that has reduced severely. I mean, Transnet will absorb big number of engineers as graduates to train them and absorb them later on. Sasol will do the same and many others. I think today you will struggle to get Sasol to even absorb 10 or 15, even if they were sponsoring them as bursary holders. The contract has changed to a point that they're saying they will fund you, but they can't guarantee you a job when you complete. And it's many similar contracts that engineering students are sitting with. What do we do then? And I think it's what brought us here, to say, what do we do then? It looks like, Prof. Majosi, as we in that demand, is that it looks like we have to dig deeper into our training institutions, universities, be it even high school and stuff like that, to say what portion can they take in this process to at least give that training such that our engineers, when they go out, they may not be expert or reactor specialist, but there's something he can fiddle with and he has seen it before and stuff like that. I can share a lot of my experiences when I started. 20 kVA transformer to me was the biggest transformer. I'm telling you, as you will not believe it. I was so excited, I told my boss that I tested the biggest transformer and he asked what size. And I said 20 kVA. He just took his hard hat, he took his PPE and he said, come, let's walk. And he showed me the biggest transformer that we had at Sasol at the time. But that was my exposure that I have. Can't we build our tertiary institutions such that an engineering faculty own or co-own with SAPREF, for example, a SAPREF processing plant for papers, or a refinery with BP, such that all chemical engineering students can really learn, touch, feel, smell what a refining plant looks like. And when they leave, they are able to touch. I think that's the approach. Whether it's possible, I don't know. But that's the question. How do we make them walk out, be able to do at least the basics before they can specialize on specific topic? That's what brought us here, just to realign.
Thank you so much. I'm going to ask Ntate Azwi just to maybe think about it and ponder it and maybe respond after we take the question from this gentleman.
Thank you. My name is Gift Mpefu. I'm from MedTech Engineers. I also happen to be a graduate of this university. MedTech Engineers has been around for over 15 years, and we are really, really proud to employ young guys like you guys here. So I'm really looking forward to providing some very, very fantastic opportunities to some of you. But for me to do that, I need to work with some of my colleagues over there, especially Mr. Azwi. I really enjoyed his talk, and you emphasized about your collaboration and interactions with academic institutions in terms of working in the innovation and technology localization, which is great. My question is, you know, we have a lot of SMEs in the engineering space or engineering consulting space. And these are the people who are actually creating more opportunities for the young guys. And these opportunities are very sustainable, I must say. But we can only create those sustainable opportunities if we have good working relationships with institutions like yourselves. So I did not get a sense that you guys are collaborating with the private sector or the SMEs in the engineering space. So could you elaborate a little bit on how you guys plan to work with engineering consulting firms in terms of realizing your goals? Thank you.
I think that's in line with probably the question that Unhlanhla asked and Tata Azwi. Maybe just to ask, how do we get to produce engineers that are ready for work, considering that the sink is full, right? Because we're going to create engineers that will be ready for opportunity, but there's no opportunity. So what should we be doing differently for the engineers to make sure that we start creating the capacity downstream to absorb the upcoming engineers? Is it a question of entrepreneurship in Tate Mondli, as you mentioned, that needs to be considered in the training? Because if you look at the industries like Eskom, Sasol, they get money from SETAs, right? Also from the qualification, they get some levies, some rebates back for training, and they can train probably more engineers without, as Nhlanhla said, the guarantee of absorption. But we can start creating a pipeline of engineering entrepreneurs that can then create the industries that will absorb the other ones. Is that the kind of thinking that Eskom is thinking of in innovation?
Yeah, it's a difficult one. A long time we used to have, for those of us who are fortunate, we used to have people who were called technicians who were studying in the University of Technologies. What they used to do, semester 1, they will do something called T1. And semester 2, they will go and do practice. And semester 3, they come back and do theory. And semester 3, they will go back, practice, and they will come and finalize. That's something that we are missing. And I'm very glad that you have mentioned the issue of SETA. Our problem is not a problem of money. And our problem is not a problem of industry shrinking. Our problem is complex. It's in the mind. You cannot tell me that there is no work for engineers when actually SETA has got money available now where they can go and deploy people to fix the sewers that are running in the townships and suburb areas. There's a problem with the way we think. We think in the box, and I've said it earlier on, that we tend to want to see the consequence of a problem and we go and solve the consequence and not the root cause. In the workspace, we have got a course called root cause analysis. It's very important that course should be taught at universities because it tells you how to think to solve the problem. What is that is really causing you to experience the problem that you are experiencing? You cannot tell me that civil engineers are not employed, whereas in many areas of the municipalities, and Dr. Mboneni has mentioned it, that people who are being appointed as engineers They haven't done engineering, and yet they are allowed to be called engineers. And we have ignored that. So it is an organization like this one where we need to challenge the status quo and go there and help. We will start by volunteering, and thereafter we work for money, because everybody who is giving a service must be paid for that. You cannot muzzle the ox that is trading the mill. So I think we need to really go back to the issue of a degree, which is 4 years, Prof. Majosi. You should have at least a full year, not 2 months. 2 months people go there and we make them to do photocopies of our projects. Now that we don't do photocopies, we make them to just go and sit in the computer and analyze, something that they don't even know what they are analyzing. We need experience before we graduate. These days, Chair Mapalala has mentioned that he did not know how big the transformer was, the biggest transformers. We have got a transformer that can be from here up to the road. That is 15 meters, just a transformer. And many people haven't seen that. So we need exposure. Engineers must be exposed, not to start thinking about anything. I used to say this when I employ a lot of engineers, about 100 of them at the same time. And I tell them that for the first 3 months, please don't think. Just check what we have. After 3 months, in your fourth month, then you start just coming up with everything innovative. We will listen to you. So what am I trying to say? I'm not saying that what you have learned is not going to contribute, but what I'm saying is that you have learned too much, such that we are going to use only 15% of what you have learned. The rest, you will use it as you move on. It sounds very contradictory. I have learned a lot. There are very few universities I didn't study in South Africa, including overseas. So I know what I'm talking about. I've done theoretical mathematics, applied physics, and then do engineering and understand where things are. And that is why I'm able to apply my mind and say, what we are missing is the experience, just to know what you are dealing with. The issue of SAPREF, you need to just have a journey where you just go there and just listen when they are explaining to you. I'm telling you that will be equivalent to 3 months of understanding that course that you had done. I studied at UCT. There was a certain course, Prof. Majosi, they used to call it CPA or CPU or something. That course was bad news. Now, it is good to understand that course, but it is also good to go and see the Fisher process at Sasol. You go and see it at Mossel Bay, Petro SA. Once you see it, then you start to understand, wow, you appreciate. And once you appreciate, then you can come up with other things and methodologies. Yeah. Collaboration with SMMEs. We have done that. We used to have a lot of consulting engineers who were assisting, particularly in ESCOM. But then the challenge came. The people who are employed, even those that were in consulting, they were designers. When they come, they change and become project managers. And the decision was made to say, no, let them design as well, because they are paid to design. So there is an opportunity that, as I mentioned, the issue of value chain. We need to know how to create value chain. When you see something happening and you see a product being developed, before you are excited that you're going to get 7 billion out of it, just try to understand what is the value chain that I am creating. Who are the people who are going to contribute to that value chain? How are we going to roll it out in other countries? We become so much full of ourselves. We are too much full program director. We are too much full of self-interest more than the interests of the country. I think there is a cause that needs to be really introduced. Some people say we need to introduce military service so that people can become patriotic. Maybe we should. But all what I'm saying is that you cannot talk about another country when you are staying in this country.
Indeed.
You need to start thinking about the problems that we are experiencing.
Yeah.
We have got problems of water as we speak. When I go where I'm staying, we have got challenges with water shedding. I will call it like that. But the challenge here is we need to also understand what is the value that I can add into that problem. And some of the problems are systematic. You go to other municipalities who are supposed to service us, they don't have budgets. Why don't they have budgets? It's because people are not paying wherever they are. So we must pay for the services that we receive. That's the value chain. Then we will be able to move forward.
Thank you, Mr. Azu. And maybe the question would be, while we take the last question on the floor, is this an opportune time to start talking about community service for engineers as part of their graduation program?
Yeah.
For 2 years, maybe we go and solve our problems in the community? So let's take a question before we get a comment.
Thank you for an opportunity. I'm very grateful for being like today, having to hear very wise and very, informing talks from people that I thought I would normally see on TV and whatnot. So my question also to people who are here, recruiters and people who are one of the big people in big organization, as students who are still on undergrad level, what is actually expected as you guys, as we finish, as you guys are recruiters, what do you expect from us? Or is some sort of anything that we can actually do in this saturated degrees to actually stand out, get those opportunities to be absorbed by these organizations that we wish to work for? Thank you.
Dr. Mondli, can I just ask you to maybe answer that? Okay. You should have yeah. Yes.
It's not.
I think it's working.
It's working.
Yeah.
Okay, thank you. The reality is, as I stated, that universities to me I'm still convinced South African universities produce the best engineers. That one you should not take away from yourselves. The limitation is that the market is not geared to absorb the number of engineers that are being produced. They are not unemployed because they cannot do their job. It's because the market is saturated. And what you can do, to me, I think I'll go back to my proposal that show interest in your space. Don't be a standby. You watch things happening. Be there, investigate, check areas of interest, and start working on those. Start establishing relations with those companies. So that I also agree with my colleague here, Mr. Azu, that it's unfortunate that I think around 1996 actually, we changed the curriculum for then what we used to call technicons, and we introduced the investor. I'm sorry to go back there. So, those people, they used to get employment whilst they're still at school because they had that 18 months in the field. They would be in class for 18 months and 18 months field, and that helped them because by the time you finish your 18 months, you know how to manage or to do anything that is in your space. At least you know enough that you are employable. The unfortunate thing is that with engineers, we expect too much when the market is shrinking. Engineers thrive in economies where there's growth in the economy and there's production in the economy, where manufacturing is thriving, where construction is thriving, and all those things. And because they are required more there. But in us, we tend, if you check, we find that we take a bigger percentage of what we consume is imported. That's one area. So what you can do to me, show interest in your field, go out and do that. But to me, I like the issue on the SMEs. Sometime I was doing my own project down the road here along the London. So I needed somebody who can do the market study. And I had to use one of the professors from VETS who was consulting in that space and use the students. So those students, they start gaining the experience in the construction, naturally in the built industry, because it was more on the built. So I'm not sure if, I think I want to second my colleague at the back there, that maybe we're not using SMEs enough in terms of exposing, because SMEs will have professional engineers to supervise students while they're still at school. From time to time, they have a place to go and practice. So I believe universities, if they can increase that partnership, not only looking at big companies that will absorb numbers, but we look at the smaller organizations that will also improve the issue of employability. But in terms of content, don't doubt yourselves. That's one thing I want to emphasize. I don't want you live here, you hear that there's unemployment of engineers, and therefore maybe there's not demand for you. There is a demand, but is that the economy is at a stage where you cannot absorb all of you at once. Hence, the issue of entrepreneurship and also trying to associate yourself with SMEs. That the other limitation we have in the country, particularly in the local government, I'll go to that because it was mentioned, is that local government, even if you appoint engineers, they are used to process tenders. They are never used to do what they are schooled for. Hence, you'll find that young people who leave local government to go and look for jobs somewhere where their skill can be practiced. You can go to any local government, the biggest thing that is done by engineering or department, they are busy compiling documents for tenders that are coming up. And so to me, I believe we have destroyed good careers just by relying too much on tenders. In the past, you'd find that even in government, they had a maintenance department that people would leave the plant, would go to the plant and maintain. This day, government, everything is tendered outside, and naturally, you find that government, nobody would want to stay long in a place where your skill is not valued. Thank you.
Samondi, thank you so much. Yes. We have Dr. Mofe on the line who's just raised a hand. What I'm hearing is community service, bring in SMMEs, maybe they can coordinate that to give the skills to the young people while they also create opportunities for themselves. Is that something we need to exploit as part of the curriculum? So Prof. Mofe, you can come through.
Yeah, thanks very much. I really just want to comment on the issue of community service, and I think this is very important. We need to reach a point where, we can actually add value to the communities. As you see, is a person might be the best engineer ever in whatever area, but there is a simple engineering problem, even in the village that you're coming from. And for the reason that you are not paid to do it, you don't. Where you might be the best person, you might be the best doctor, the best scientist or whatever, but you just don't want to do anything in the community because you are not going to be paid for it. And I think that really comes to how do we perhaps configure our programs going forward. And I think it would be important to then say, before you really graduate, this is what you need to submit as a community project that you have started and that you have done. So that even when you go back or when you're driving past, you can say the project there that is dealing with things like A, B, C, D. Now we've got energy crisis. We've got young people, young graduates who can design and implement bioreactors and stuff like that. So for me, that mentality of saying learning shouldn't just really be about, I'm going to do this thing because I'm going to get a piece of paper or I'm going to get money, but it also must be, what value do I add? And as somebody once said, talking about universities, I think it's Professor Chris Brink, he says, universities, and he was saying the universities must have a soul so that it can have an impact. It doesn't help. Universities today are, not all of them, okay. Sometimes they chase things like, oh, I'm the best university, I'm ranked this and that. And you are a university in an area where, for example, there is a huge problem around water quality. And your students have never ventured into that community to say, we are analytical chemistry students, we are chemical engineering students, we are this, we can provide solutions. So that really is where sometimes we become so irrelevant that without thinking about what we can do to our communities, I think we will forever be backing this thing of saying, why are we actually even not developing as a country? So I think we need to really think that way. Thanks very much.
Take the last question from Tebogo. We've overrun our session. It's also late. It's a school night, students. All right. So Tebogo online, please come through, and then we're going to take closing remarks, right? We're going to start with you, Mr. Mondli. Short, precise, Prof, right? Thank you. Tebogo, we're waiting for you. Please come through. You raised your hand.
Hello? Can you hear me? I'm not sure if I'm audible. Yes, we can hear you. Oh, okay. Yes, mine I think is just a comment based on what has been said today. I think I can say I'm privileged to be an engineer of today. Within the fact that I've seen Prof. Mashao there. Prof. Mashao actually was my lecturer when I was studying at UCT. He was my Python lecturer. And what I want to say to the student is that being multi-dimensional, diversifying, I think we touched on the issue of elective courses that students get to choose from. I think that is very important also in determining your career progression in engineering. I'm just going to use myself as an example. I studied, I'm an electrical engineer by profession, but in my time when I was studying undergraduate, I made sure that I diversify, or well, maybe the university also allowed me to do that, where I majored in nuclear engineering, I majored in power systems analysis, control and automation, and also I majored in power machines and drive. And I think that being said, it also gave me an edge to be able to somehow maneuver the engineering fields, in a sense saying that I was an EIT for Eskom, which laid a very good foundation, and I'm very privileged to have been an EIT and a bursar from Eskom, and I did serve the organization for quite a considerable time. And that also allowed me to, when I left Eskom, I managed to work for companies like ABB. I managed to work, I was in the mining industry, but on the side of designing machines, mining machinery. And currently I'm in the nuclear industry. So what I want to say to our fellow students is they shouldn't be focused on one thing. If you have an opportunity to diversify, choose different courses as your majors or as your electives, do that, because that will give you a competitive edge. And also do not just only look at money, because I believe the young generation is more motivated by money more than anything. And the things we talk about in terms of engineering is a thinking tool. Hence, engineers can be employed in almost any sector that there is. We are problem solvers more than just being engineers. Hence, the issue of looking into problems that are facing our country and our communities today, it will take an engineer's thinking cap to solve most of them. And hence the issue of community service comes in as one of the good recommendations for us to include in our system, either university system or as part of the requirements into employment, because that will give them an opportunity to apply their thinking, probably either under supervision or on their own, and that allows them to be innovative without having been polluted. I might be using the wrong term, by industry and other people who might have put in other ideas, but it gives them that freedom to apply themselves and explore that entrepreneurial side of things and the innovative side of things. And then the other thing that I have here is to say, what are we doing in terms of collaborating with the professional bodies? You know, the EXAs, you've got your INCOSI, you've got all your South African Institute of Electrical Engineers and all these other professional bodies that exist, because I believe those have multitudes of professionals who can probably partner with universities to take in some of these young people and maybe job shadowing or something, just to expose them to what is out there if they couldn't get that through the university streamline training or vacation work. And then also, I wanted to my last comment is to say, with the universities, we have to employ systems thinking or include it somewhere, somehow in the curriculum, so that the engineering student can understand that when you solve a problem, you're not just solving the symptoms, but you're looking at, I think, as we mentioned, value chain, but you're looking at it, systemically, applying systems engineering, because it starts from the beginning, from design or from requirements capturing to when you produce a product at the end in manufacturing, and also post product being with the client or the customer. What do you do after?
So we need to do closing remarks. I think in essence, the question that asked is, how do we make or develop or produce industry-ready engineers? And I think there's a lot of insights that the engineers have. So that we don't sound preachy, because it looks like we are preaching to them, is how do we close the gap? Now what? Right? Now what? The sink is full. South Africa has many problems in our community, in our doorstep. Just coming through to UJ, you look at the flats on the side, you look at a lot of things that just needs to be done, right? How do we bring that knowledge out to the fore? So for today, for now, what are the next steps? What should the graduates and the engineers on the call consider in order to enable South Africa to succeed through the engineering expertise that we're training through the universities and that exist at home with our jobs?
Mine, I'll allow my Leonard colleagues to talk on the future, but I would like to talk to the young person. The problem we have, we see ourselves as Umonde. Umonde is a brand. When you develop yourself as a person, you came here to study engineering. What brand are you creating? It's important that you start knowing now that this is Monde's brand. Brand will cover the issue of knowing your subject, being an expert on what you were taught at school. Number two, being able to represent your brand in every forum where you are exposed. Number three is your attitude towards your work, how you see yourself and the value you add. We sometimes, young people, once they know this much, they get too excited, not knowing that the world is bigger than that. Try and find your niche in that, but without being boisterous, but being confident in that. And in that, you'll be able to grow into the real brand that companies will be chasing you than you chasing companies. Let's move away from the culture of being beggars. At some point, we need to sell ourselves as if we are selling, see yourself as a product. Thank you.
Yeah, I really think that a lot has been said already. I differ just slightly with my colleagues. I think money is everything, and don't let anyone fool you that money is not important. It is very important, and I think that and I think we should understand why it becomes so difficult for our kids not to go and work for free. The background or the life of a black person, unfortunately, at this stage does not allow for us to do that for free. And that's the reality, okay? In other countries, it's different. In fact, if you look at medicine, if you look at accounting, if you look at law, you do have internships, but they're funded in one way or another. So it has to be funded. And we should not, pussyfoot around that. That is how it's supposed to be. And then the one thing that I also want to mention is Palace. I don't think that there will ever be an instance where universities produce ready-made academics, or let me say students, graduates. It will never happen, because there is always a gap that needs to be crossed between what you learn at a university in terms of theory, because that theory is important, and what you have to do in industry. And unfortunately, there's no one institution that can do that.
That is why in the past there was that complementarity. The technicals were looking more on the practical side of things with the limited theory. Universities were looking more at the theoretical side of things with limited practice. And these two complemented each other very well. We destroyed that. So we have to go back and do that. It's important that you learn that theory, you understand it before you do practice. There's room for that. As soon as we stop doing that, we are doomed, right? So that's my only contribution here. Thank you.
Yeah. Thanks, Prof. Yeah, I think, yeah, from my side, I totally agree with what the Prof has said and what Mr. Mondi has said as well. I'm just going to divert so that stimulate your thinking and your minds. Engineers are very competitive. Mainly people who study engineering, they got 7 A's, 5 A's. And that mentality filters into the working environment. In fact, it troubles many of them when they are still studying. You cannot study engineering and you are not belonging to a group. Because most of the solutions that you have, you need to think about them collaboratively. Engineering says you come up with a solution and somebody must question that solution until you have 8 alternatives. So because of that, we become so competitive that even in the workplace, I want to be the very first person, I think, Sakho, you have mentioned it, to be promoted to be a senior engineer. I want to be the very first person to be promoted to be a senior engineer. Whilst you are still studying, I want to be the very first person to be on the dean's list on 4 courses. All those things, you need to think in a very systematic manner. We are in a country where that competitiveness, it doesn't help us much. We've got a saying which is mutundi mutunga bamwe batu, which means we are a community because of one individual as we move on. Umuntu ngabanye abantu. We need to start thinking about those issues. We have thrown away all those values and we adopted some values which are not taking us anywhere. Look, we have got a lot of problems in our country related to all those things that we have mentioned. And yet we have got the best educated people who are being absorbed by other countries. So it does not help us to be the best doctor in South Africa when you cannot solve the problem of malaria in Limpopo. So I would say that we need to work together and build this beautiful country of ours so that we can make South Africa a better place for all. And when we say a better place for all, it means that when you solve a problem, make sure that the other person as well is included in that solution. It cannot be an individualistic. And for me, part of the elective courses, I think we need to have some social science elective courses to be given to engineers. Because we are operating in a world that will continuously frustrate you. Why? Because you are living, you are having a frame of mind, first world frame of mind in terms of thinking, and you need to operate in a third world environment. So those are some of the things that will really help us. I think my take home here, you really stimulated my mind when you talked about community service. I think that is something that we need to really start fostering now. It will really help us going forward. Thank you.
So can we take it as an action for the technical advisory bodies? On a serious note?
Yeah.
I mean, we have CETAs that have money, URF has money.
Yes.
And somebody's been given 7 billion to create jobs. Should we not put it into training graduates in solving community problems for 2 years?
It's true.
Yes.
But you fund it.
The UIF will fund it. Right? Give them a stipend. We already have a model with the medical practitioners. So we're not starting from scratch. We're just saying, after graduation, 2 years in Tsakane. Let's go sort out the potholes, the sewer issues, the water issues in Tsakane. You know what I mean?
Actually, in our last advisory meeting with UJ, there is a certain professor who contacted me where he said, you are speaking my language.
And all what we are going to do now, we are going to come up with a way of making sure that we absorb some of those students and put them in some of the challenges that we are experiencing. And then they will be administering those students.
And we bring the
learners as well.
SMMEs as well, because
And the
they can do
SMMEs.
the supervisory,
Yes.
the training, the IDPs as well.
Yeah.
And we bring Salga to just tell us where the pain points are in the country.
Yes.
Let's deploy our engineers who are graduates are sitting at home.
Yes.
I'm going to ask Dr. Mofi, if he's still online, just to give us his final remarks, and then we're then going to ask. Kudzai has been asking me here, this gentleman, I thought he was one of the panelists because he's so dressed. He has a question for you, Prof, and he says it cannot leave the room.
Is it?
Or it cannot what do you call it? He can't leave without having answered it. But we run out of time. So Dr. Mofu, then the quick question, then vote of thanks from Untlandla.
I'm beginning to like the language that is being spoken here. And I just want to go back into the issue of the people that are here. We actually have got ideas that can solve a whole lot of problems. So we got people from government, we got people from academia, we got people from private sector, we got people from state-owned entities and so on and so forth. And I think for me, it's how do we take up a call so that, for example, Azri is able to say to me, we are actually looking at this area of technology. Did you guys fund it, or are you intending to fund it? It didn't work like that. And I'm really wanting to take on this issue around training and internship and community service. That if we can really put our heads together, I've got a lot of programs that I'm doing on what we call partnering with municipalities to try and solve their problems. If we can really work together, and maybe we can even have a proposal, and I can really see how can we actually fund such a proposal where we can deploy some of these people to do some work. And I think jointly, if we do that, and also the private sector can contribute, we can really get something going. So I just want to say, let's really have this as actionable things where we can begin to see that we are making impact as professionals. And as I say, the bulk of us, we are here, we can talk to one another and come up with tangible programs to solve the challenges that we're dealing with. Thank you.
Please, no speech, just a question.
Yeah,
Prof,
please.
also,
No speech.
No speech, thank you.
Thank you very much. My name is Kudzai Zutai. I am a civil engineering student here at UJ. So my question here is for a lot of students that are in here, is we were looking at graduate engineers, right? What happens in between here, from first year to final year? Because here at UJ, there's a notion that engineering is 4 years, but it takes 6 years to finish, which we made it a joke. So my question is, what is being done here at institutions that prevents, it's worldwide, understand? The phenomenon of people taking longer to finish, and academia, or should I say the private sector, wants an average of 65% in the conventional way. So as you was, engineer, as you was talking about thinking outside the box, being dynamic. So how do you then perform being dynamic under the same institution that thinks in a systematic way? So my question is, what's been happening here from first year to final year, retention and success rate? We have 120 students coming in, but only 10 graduate or 5 graduate in record time. What's the problem in there? Thank you.
I think it's a legacy question. Remember first year, some of them who goes to UCT, look around to your left, to the right, and you see that you might not be finishing.
That's a very, very good question. In fact, that never comes in the deliberations or discussions that we have. We assume it's 4 years. On average, it's not 4 years. And there's nothing wrong with that, by the way. There are many good reasons why it doesn't end up being 4 years. But different institutions will have different interventions. What we have at Wits University are the academic development units. So each and every faculty has such a unit whose task it is to take the student by the hand from the first time they come to the university to the last end when they graduate. So here you have tutors who you can walk into their rooms at any given point in time on any subject that is pertinent to your studies, and they are ready to assist in one way or another. We also have boot camps, which would take place maybe around June, December, thereabout, to assist students who really need further help. So we've created structures with that in mind, that most students tend not to be on their own or succeed on their own, so they need a lot of help, which is understandable. And we've put structures in place for that to happen. So on average, it's about 5 to 6 years, thereabout. So if we took that time, don't worry about it. That's more or less how long it takes.
So what we'll do, we'll take it as another topic. You guys said you'd like to have some of these similar interactions in the future. So maybe we'll bring in people to say, how do you get to graduate in record time, right? What's the master plan? So I'll hand over to Nhlanhla. So otherwise, thank you guys so much for staying through the session. I know it's a Tuesday night, and for us, it's just encouraging, which means we must visit you more often.
Thank you very much. Thank you very much. I come right at the end because I was busy telling her, close, 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 close. And thank you to the audience, and both on the social media and those that have managed to stay up until the end of the event. I can't leave my speakers. So professional, so well prepared, so patient as well. At some point, I was worried that they will get impatient and leave us. You know, some of these problems, sometimes they just happen and you never plan for it. You can really do your risk analysis up to the T, but there's always a security at the gate that will say, we don't know about that event, you are not coming in. And then everything changes. But thank you very much. I understand I've gotten Prof. Majozi's presentation, and you also had a presentation. Please share, as I know as well you had. Please share so that we can share with all the participants here. I think in terms of the next step, my lady, she knows how we roll. It's our culture that the issue that came out of this seminar or the discussion is that there is a proposal of the funded community service. I'm underlining funded. Please, our children can't just be used as extra labor for free and then they get disposed. Community service model, out of the speakers that we have here, we're gonna create a small group of 5, 6, 7 people, a working group, and we workshop this yes, we workshop this, we try to make it implementable, and thereafter we can come back and report on what came out of these discussions. And that, I'm happy that Dr. Mufe is also committed to fund it. So guys, we have everything. Literally, we have everything. We just need to put the model together and implement it, and funding is there. And yes, guys, I will not stretch, I will not talk any further, but thank you very much, and we hope to see you in future. And guys, let's keep talking. Let's keep these discussions going. I'm very passionate about student development, training. It's my area. I will tell you more one day when we have a lot of time of what I do. Thank you. Oh, how can I forget? Next thing, we're not gonna come here. Yo. Wait, there are two stakeholders that I have not thanked. Thank you to the ESCO of ELP for arranging this and working hard. I know they're really doubling up because they are working, their families, and none of them are single, so it's really a problem. Especially with women, it's like, my husband is not well, I can't do this anymore. It's like, and it's done once they say that. Also, thank you, Precious. Thank you very much for also hosting us here and arranging the venue for us. We really appreciate. I know we have to, you did allude that we need to improve our communication. We will do that going forward. But Prof. Mashao, in your absence, we also thank you for letting us in. I think he has really opened his hands and he says, at any point we can come here and really discuss anything engineering. That's what he said. No politics, anything engineering. So we'll always come here. Thank you guys, thank you very much. Travel safe.
Hey, Kuzai, how are you? No, good. Now, when I'm looking at you, then I check my phone. I said, no, man.